Oh no.
I said, hey, I'll test it for you. I'll let you know how it works.
His skies will be clear since he's not in town and it's sitting on his doorstep.
I mean, I don't mind because we live in the same town.
Dark,
so if
steady night.
I wouldn't mind the skies clearing up. Yeah, it's been cloudy here the last couple nights. Looks like it's gonna not clear up for a bit. So, but I had a really good September. I got lots of imaging done in September.
Where are you, Molly?
I'm in Dayton, Ohio. See, I have a backyard setup, so I can image on nights where the forecast is not looking favorable and it ends up clearing out anyway. I can image on nights where it's only going to be clear half the night. As long as there's no rain in the forecast, I'll uncover the scopes and image and just see what I can get.
What are you going to do this winter? You're going to leave them out?
Yep.
Yeah.
I might get some like 100-watt light bulbs to put underneath of them.
Yeah.
Depending on how things go. But yeah, we'll see how things go. I think, that that grease that's in there should be good down to, some temperature, and it doesn't get super cold here. It just gets like kind of cold. So
yeah, it just gets muddy and nasty here. Yeah.
Yeah. So, yep, that's the plan. And then I'll be able to run at really cold temperatures on the camera. So that'll be
everything will be nice and cool naturally. Yeah,
I can run it like -25. I've never run lower than -25, but we'll see what happens this winter. I don't have dark. I barely have enough darks for -25. But now that I have a permanent setup, I can get darks on cloudy nights and fill out the rest of my darks library.
Yeah, it's supposed to, I think, clear off for tomorrow night, I believe.
Oh.
I think so anyway. I haven't quite got that far because I was looking at the same thing. Yeah,
it was supposed to rain today. Oh, it's going to rain tonight. But tomorrow night, actually, yeah, it looks like it's going to clear out about midnight.
Yep. So,
well, Terry, I'll send some of these wonderful 40-degree temperatures your way because we're having a really cold night tonight. I'm out of town in Springfield, Missouri, but it's going to be cold tonight. But it's cleared off finally.
Yeah, it's only it's
38 here in Arkansas. So
wow,
oh, wow,
yeah, we're getting down there.
Cold.
Yeah, temperature's going to drop tonight. It was in the like 80s yesterday and in the mid 70s today, but tomorrow it's only going to be 59 with a low of 41. So
I saw that
cool off a bit.
Yeah, with this rain, the cold front's coming in behind it.
Oh yeah, it does look like that. Yeah, it looks like we're actually going to be clear the next several nights.
Yeah, it looks like Sunday's going to be good too.
Yay.
Yep. John's just sitting there smiling away like, yeah.
Yeah. The backyard setup is so nice. Oh, and I got my science rig back up now for doing variable star observing. So
yeah. Were you here when I said Barb Harris won't be here tonight?
Yeah.
Okay. Yeah, she wasn't. We'll catch her next time.
Okay. Yeah, I'm really behind. I have like 2 months worth of variable star data from earlier this year, like February and March, and I think a little in April that I haven't processed yet.
Yeah.
I've been trying to come up with a way to automate more of the pre-processing, like to automate the calibration and file conversion, but I haven't figured out kind of a way to standardize that yet. So I have to go pull the correct darks and flats, and then if it's 1x1 binning, I got to use one cosmetic correction process. If it's 2x2, I got to use a different cosmetic correction process. And so I haven't quite figured out how to boil it down to something that I can put into like a process container yet.
Give it time. Winter's coming up. That'll make it a little bit easier.
Yeah, I am planning on writing some scripts to auto pull calibration files for me, but it's going to be a lot of work.
Well, hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance. And it's my great pleasure to announce the Astronomical League Live number 10. The celebration has to do with there is actually a connection between, the major holiday of this month, which is Halloween. That is All Hallows Eve, or it's also known as the Cross Quarter Day, which has to do with the interval of between the equinoxes. So it is a day more or less midway between an equinox when the sun sets due west and a solstice when the sun sets at its most northern or southern point on the horizon. The host of this program is Terry Mann. She has an incredible lineup of speakers, as she does on every Astronomical League live program. And I'm going to turn it over to her. Thanks, Terry.
Thank you, Scott. I love that introduction and the Hubble. That was really good. I like that. Were you doing sound effects or was that actually?
That was me. Yeah,
That's
was
what
me.
I thought.
Right. I had this whole thing set up. So
that works. All right. Well, thank you, Scott. Thanks for hosting this. We really appreciate it. And thanks for just helping us out as much as you have. You have really been a great support for the Astronomical League. So, and we really do appreciate that.
It's my great pleasure. Thank you.
I am going to turn this over to David Levy, and he will do our celestial incantations. So, David, I will turn this over to you.
Well, thank you very much, Terry. It's good to see all of you. It's good to see you, Mary, and John, and Carol, and Molly, and Scotty, and all of my friends here. And this is Halloween, so I'm going to try to be as scary as I possibly can, which is not very scary. My poetic invocation tonight is going to be from one of the scariest writers of all of English literature, Edgar Allan Poe. No, I'm not going to read from The Raven, quotes The Raven, nevermore, even though Jean and Carolyn Shoemaker had two wild ravens that actually lived near them. And of course, they called them Never and More. Instead, I'm going to read a poem. Did you know, everybody, that Edgar Poe was an astronomer? And he, do you know the story about the night sky being dark? It shouldn't be dark. When you look up at the night sky, every square inch of sky should be brighter than the sun. Because, you have 21st magnitude stars, and you have 106 magnitude stars, and you have a zillion 20th magnitude stars, and it keeps on going. So every square inch should be as bright as the sun. It is not true. The night sky is dark. And Albers Paradox is the famous theory. I'm not going to go into that, but you know who first suggested that? I don't think it was Albers. I think it was actually Edgar Allan Poe. Kind of interesting. Need to look a little bit more up about that. Anyway, my poem for today will be from Al-Araf. It's a poem a very long poem, so you better sit down. It's going to take me about 4 days to read this. And so Terry, relax, everybody get a good nap. And this is originally written, I believe, to celebrate the supernova of 1572. And it probably took him 20 years to write it, but here goes. Spirit, thou dwellest where? In the deep sky. The terrible and fair in beauty vie. Beyond the line of blue, the boundary of the steam, which turneth at the view of thy barrier and thy bar, of the barrier overwon by the comets who were cast from their pride and from their throne, to be drudges till the last, to be carriers of fire of the red fire of the heart, with speed that may not tire, and with pain that shall not part. Who livest that we know, in eternity we feel, but the shadow of whose brow what spirit shall reveal. Thank you, Terry. Back to you. Didn't take quite 4 days.
I was going to say 4 days just buzzed by so quickly. I must have fell asleep. Thank you, David. We really appreciate you being
Thank you.
here. Oh,
Thanks.
Carroll
I love
Iorg,
it.
you're not. Oh, I'm sorry, David. What?
Just said I love being here, and I really appreciate the honor to be part of the league this way.
Well, we are sure glad you are here, and you're welcome anytime and all the time. I keep every Astronomical League Live we have, I always say, David, can you make it? So, all right, Carroll Iorg, I know you're here. I know you're not home, you said. How about if we go to you and we'll just kind of make you the wizard of this program tonight. So if you would, you go ahead and give us an update or whatever else you would like to tell us.
Well, this wizard doesn't have too much experience with Halloween related things, except I can be scary occasionally, but we'll let that happen for another time, maybe. David, you set the pace for us. You said it just right. And thank you, Scott, Terry, and everybody else for making this such a fabulous thing we do each month for the Astronomical League. I'd like to give just a few updates from the league. The first one is that we have 20,000 people as members of our organization. And it really points out the fact that throughout the pandemic and everything else, we have really had an increasing interest, not an increasing interest, but a return to the interest in astronomy. Of course, Scott, we have all talked about these factors before. Vendors just can't get enough of telescopic equipment and other astronomical equipment. And we are seeing the same phenomena as far as the membership numbers for the Astronomical League. And I would like to give just a few updates. By the end of the year, we hope to have our new and improved website, which will be functional and really exciting to look forward to. And the other thing, just some reminders as we set the scene for doing the Halloween type stuff. This is a good chance to go out and do some observing in these night skies as it gets cooler in the fall. It's a perfect time to go out there. And as all the astronomers, professional astronomers say, I should say professional amateur astronomers, in the winter is when you get those good views if you can handle the extreme temperatures. And it's a good sign. I've been reminded the last couple of days of it being close to the winter season and the fall season. So the other thing I just remind everybody is that whatever you want to observe, there is something for you in the Astronomical League. Whether you live in an urban area and have light pollution, or whether you live in the most dark sky type areas of the country and the world, there is something for everyone as far as our lineup of observing award programs. And we have roughly 80, a few more actually, and there's something for everyone, whether you're an imager, whether you are more into visual, or whatever there is, there's something for you. I'd just like to remind everybody of the upcoming calendar. Thanks to Scott, Terry, Chuck Allen, and everybody else who made our virtual convention for 2021 so successful. We're going to follow up on that in 2022 and try for the third time to have our convention in Albuquerque. And I know David Levy has already promised that he will be there. And the Albuquerque club has been very patient with us, and they're saying we will stick around for the third try at this, and we're going to make it happen this time.
Really looking forward to it,
Yeah.
especially because it's the Albuquerque group is so wonderful, the league is wonderful, and our grandchildren live there. So that's really a lock-in for.
Yeah, I think David's about 100% sure he's going to be there. We're so delighted to always have you there for our events, David. The other upcoming events past this year, as far as Alcons, we're going to, in 2023, we're going to Baton Rouge, Louisiana. That should promise to be a very good event. We haven't been to that area of the country for several years, so we're really looking forward to it.
I have family there.
Oh, it's not another excuse for another person to go.
Yeah.
And beyond that, then, we have an upcoming, all the details haven't been worked out of the rest of the upcoming lineup. However, we'll be going back to Bryce Canyon. As some of you may know or remember, back in 2011, we went to Bryce Canyon and saw some of the darkest skies in the country. And we still have lots of rave views. And Terry Mann has promised me that Lowell Line and others are going to pull that off again. So it's a good experience. And then finally, we are going to extend our international influence. We had a taste of that on our virtual 2021 with our speaker from the UK, which was an outstanding situation, one of the better outcomes we've had lately. And we want to extend that international theme by teaming with the Royal Astronomical Society of Canada and probably 2025 in Toronto. So another reason for David Levy to follow the league, since I know he's a member of that group and also a citizen of Canada. So that gives us a lot of things to look forward to. We're very excited for the future. We've almost, it's almost like we're having another renaissance in astronomy. It seems like after each major comet or something like that we've had in the past, we've had a resurgence in interest. But what we're seeing right now seems to trump every bit of that, because it's really getting a ton of interest from all quarters. So a lot to look forward to. And Terry, thank you so much, and back to you.
Thank you, Carol. Actually, I am looking forward to going to Albuquerque. I went ahead and went out west this year, but it'll give me another opportunity to travel the other direction after I leave Albuquerque. So I am looking forward to that. And it looks like it probably will happen. So, you know,
I think the odds are getting better all the time.
Yeah, I do too. I really appreciate the Albuquerque group also hanging in there. I know it's been a long time. It'll be nice to see everybody again in person. It seems like it has been so long, you know, that we've actually been anywhere in person. So I'm looking forward to that. So I am going to share my screen. I am going to do the 3 questions. We have door prizes tonight. And tonight's door prizes are going to be the Astronomical League tote bags, because you have to have somewhere to put your Halloween candy. So there will be 3 winners, and we will give away 3 tote bags. I'm trying to get there we go. And with this, please send your answers to secretary@astroleague.org. And if you would, send them within the next 30 minutes, because I will need to work on the winners while one of the speakers is speaking. And I will announce the winner after the last speaker, which will be Mary Adams. So I will announce the winners then. So please send your answers as quickly as you can. And once we announce the winners, someone from the Astronomical League will contact the winners with the information that we will need to send the door prizes. And again, please send your answers to secretary@astroleague.org. And here are the questions. We have a lunar eclipse coming up on Friday, November 19th. I'm looking forward to that. So everybody say no clouds. I'd like to see it from home. Now, is this a total lunar eclipse? True or false? Next, what telescope just took a 16-day ocean voyage that covered 5,800 miles? The telescope has arrived in the French Guiana to prepare for its December 18th launch? Again, answers to secretary at astroleague.org. And the last question, what date does the Orionid meteor shower peak this year? All right, I am going to stop there. And we are going to go to Molly Wakeling. Molly's here in my area. We were just discussing cloudy skies and what it has been like. Molly is Astro Molly, got into astrophotography in July of 2015 after receiving her first telescope. And I think, Molly, I think I've got the wrong one here, but I'm going to go ahead and read this anyway. She has moved back to the Midwest here, and she has got 3 rigs set up in her backyard, including one dedicated to variable star and exoplanet transit observation. She won first place in the Astronomical League's 2021 Wilhelmina Fleming Award and second place in the Deep Sky category of the 2017 Astronomical League Imaging Award. Molly is actively involved in STEM outreach, having accrued more than 160 hours of volunteer activities reaching over 50,000 people in person and virtually. She is a AA VSO ambassador and an Explore Alliance ambassador, and is a panelist and broadcaster on the Astro Imaging Channel YouTube show. Molly is currently pursuing her PhD in nuclear engineering. So Molly, welcome. I know you've been here before, but welcome again. And I will turn this over to you.
All right. Well, thank you for the introduction, Terry. And I'm thrilled to be among such a group of esteemed astronomers. This is awesome. I love doing the Astronomical League events and the Explore Alliance events and whatever other events I get to do. So my chosen topic for this evening is spooky nebula of the night. So let me share my screen here. All right. Get my notes up here. So humans love to give fun names and ascribe human-like features of objects that we see in the night sky, and those can be fun and happy things, and those can be kind of spooky and weird things, and humans are very obsessed with that. So there's a whole bunch of these in the sky. So I've kind of made a list of some of my favorites and some of the coolest ones and some of the ones that have really cool stories attached to them as well. So of course, the first one I have to mention is the Skull Nebula. And this photo here is from my Aussie friend, Terry Robeson. I put as many of my pictures in here as I could, but I've not imaged the Skull Nebula yet. So, but I have seen it visually through a large telescope when I was in the Southern Hemisphere in Chile, and that was really cool to see. So this is a planetary nebula. It's in the constellation Cetus, Cetus is the sea monster which Perseus was sent to slay in order to rescue Andromeda, whose mother Cassiopeia had earned the wrath of Poseidon after saying that she and Andromeda were more beautiful than the Nereids, or the sea nymphs. So the constellation being named for the sea monster that Perseus had to fight. And it's 1,600 light years away. It has a lot of hydrogen and oxygen light in it. So if you're going to look at it visually, really cool to use like a O3 filter to see it really nicely. Also along the lines of Greek mythology is the Medusa Nebula. This is also a planetary nebula, although it was originally thought that it was a supernova remnant given its odd shape. It's in the constellation Gemini and was discovered in 1955 by George Abel at UCLA as part of the Abel list of objects. And it's 1,500 light years away. This is one of my images of it from my backyard using narrowband filters to get those cool colors on it through all the light pollution that I have. Well, this one doesn't have a scary name, but I think it's kind of a freaky looking nebula. It reminds me of how the Skull Nebula looks visually, except this one is almost perfectly spherical. It's 2.5 light years across. It is also a planetary nebula, and it's expanding at 35 kilometers per second. So you think about, I mean, space is big, so we're not going to see this visibly expanding over a given night, but over years of observations, it has been observed to be expanding, and 35 kilometers per second in Earth terms is pretty darn fast.
Yes.
And I love the kind of the spooky sort of grayish blue color that it has, and the very blue star at the center. It's just sort of a spooky looking object. Now, I know I said I was going to talk about spooky nebulae, but there was one galaxy in particular that I wanted to include in this display of spooky objects, and that is the Black Eye galaxy. It's just so creepy to look at. It's like this eye that's pointed a little bit away from you, but this heavily lidded eye, Messier 64. It's in the constellation of Coma Berenices. It's also called the Sleeping Beauty Galaxy or the Evil Eye Galaxy for reasons that are clear looking at this picture. It's 17.3 million light years away. And what's really kind of spooky about it too is that it's actually made up of two counter-rotating disks. So the central disk is rotating in the opposite direction as the outer disk there. Although the stars in this galaxy are not counter-rotating, it's actually just the gas. So it's got some really weird morphology. It's thought that it was probably a gas-rich galaxy that collided with another galaxy here, or that this galaxy has been accreting intergalactic gas onto it. So there's some various theories, but yeah, it's a really cool, creepy looking galaxy. And all of the kind of black eye portion of it are really thick dust clouds that are kind of near the core of it. Hubble has a great picture of the core of this galaxy. Of course, you have to talk about some body parts as well when it comes to things that can be kind of spooky. So we have the Heart Nebula, and the Heart Nebula has this really cool, intricate, twisted structure in the center. So it's cool to image both wide field to see the whole heart shape, and also narrow field zoomed in on that twisted structure in the center. This is an Emission Nebula, so new stars are born here out of the ashes of old stars. It's in the constellation of Cassiopeia. This is Andromeda's mother, whose vanity it was that caused Andromeda to be tied to a rock on the ocean to be devoured by a sea monster. But because of her vanity, she wasn't just placed in the sky. She was placed in the sky tied to a chair and hangs upside down for part of the year as part of her punishment, according to the Greek mythology. This nebula is 7,500 light years away, and some of its stars are 50 times the mass of the sun. So just enormous, enormous stars here. And you can't talk about the Heart Nebula without talking about the Soul Nebula. They're kind of together in one structure of the sky. The last image was a sort of a natural color image of it, and this is a narrowband image of it. This is not one of mine. This is data from Stephen Miller that I processed myself as part of something that the Astro Imaging channel was working on. This is also an Emission Nebula, also in the constellation Cassiopeia, right next door to the Heart Nebula, also 7,500 light years away. Now, in the Soul Nebula, there is a really bright radio source known as Westerhout 5, and it spans an area the size of 4 full moons. And it contains large cavities of gas that have been carved out by radiation and stellar wind from some of the massive stars within the Soul Nebula. So a lot of really violent actions going on in a lot of these nebulae, even though they're happening very slowly on human timescales. There's, of course, the Helix Nebula, which is also commonly called the Eye of God, or my favorite, the Eye of Sauron. if you're a Lord of the Rings family, like I and my family are. It is a planetary nebula, but it's really close to us. It's only 650 light years away. So it appears very large on our sky, and that also makes it difficult to visually observe, but it does show up pretty readily in pictures. And it's also expanding extremely fast. It's expanding at 31 kilometers per second. And this is a Hubble Space Telescope image of it. And it really does kind of look like a giant, of all of the planetary nebula, I think this one looks the most like an eye, especially with all of the fine globules that really just look like an iris and this huge dilated pupil in the middle. And you can kind of see the eyelid in the hydrogen alpha gas around the edges. It just really looks like an eye. Now, there's a whole class of nebula that are called dark nebulae. And these are actually molecular dust and dust particles that absorb the light and obscure the light from stars that are behind them. And this is called the Snake Nebula, this one imaged here in the center. And I actually kind of see a bit of a shape of the head of a bull in the lower left part of this image. I took this at the 2017 Texas Star Party, I think it was. Actually with my DSLR. It's so dark out there that you can see these dark nebula both with the camera very readily and also at the eyepiece. You can see a lot of these dark nebula out there. It's in the constellation of Ophiuchus, so it's very close to the direction of the core of the galaxy. Ophiuchus, what's really fitting about the Snake Nebula being in the constellation of Ophiuchus is that Ophiuchus is known as the serpent bearer in Greek and Roman mythology. Some later myths had Ophiuchus as a representation of Laocoon, who's the Trojan priest of Poseidon, who warned the Trojans about the Trojan horse. He was later killed by a pair of sea serpents who was sent by the gods as punishment. Alternatively, Ophiuchus is seen as Asclepius, a doctor who discovered how to avoid death when he watched one serpent bring herbs to another serpent that healed that serpent. But of course, Zeus killed him with a bolt of lightning in order to avoid the human race from becoming immortal from this doctor discovering how to prevent death. So lots of snakes around the Snake Nebula. It's also 650 light years away. And so these dark nebula, they include a lot of different types of particles in them. They're dust particles that are coated in frozen carbon monoxide and nitrogen. They also contain hydrogen, helium, ammonia, formaldehyde, which is the stuff that's used to embalm dead bodies, and other organic molecules. I find it really fascinating that there's actually a lot of organic chemistry happening out in space, and a lot of that has been observed with radio telescopes. And you can kind of imagine that, and there's some thought that Earth wasn't just sort of a soup of carbons and hydrogens and oxygens that came together. There's organic molecules being made out in space that almost certainly had to do with the amino acids and proteins and other things being generated here on Earth that eventually led to us. Up in the constellation Orion is a reflection nebula known as the Witch Head Nebula. And it's just sort of a very spooky looking nebula because as opposed to being an emission nebula that glows red, this is a reflection nebula that reflects the blue starlight from Rigel, which is the bright star up in the name of the image here. And it's also blue because the dust also appears blue because the dust reflects more blue light than red light in a similar way that the sky above our planet tends to reflect blue light preferentially. It's about 900 light years away. And I don't think it's very easy to observe, especially because its size is very large, but it shows up really nicely in cameras and makes for this very kind of spooky, like a spell working its way toward you. And this image is from the Digitized Sky Survey. On the topic of witches, there's also the Witch's Broom Nebula, also known as the Western Veil Nebula more commonly, which is part of the Cygnus Loop. The Cygnus Loop is actually a supernova remnant. When a star about 20 times the mass of the sun went supernova about 10 to 20,000 years ago. And whoever was around at that time would have seen that this supernova was brighter than Venus and could be seen during the day. It's up on the constellation Cygnus, 2,400 light years away. The whole nebula is enormous. It covers the area of 3 degrees, which is 36 full moons in area. And it's expanding at 1.5 million kilometers per hour. So there's so much energy from the supernova, and it's just blasting out into space at these incredible speeds. And this part of the nebula is being lit by the star here. It has really this very intricate filamentary structure that kind of looks like a broom that a witch might sit upon. We also have the Ghost Nebula. This is an atom block image from Mount Lemmon. And yeah, I mean, it looks like a ghost. What else can you say about it? This is some dark nebula and reflection nebula together. It's got some really kind of other ghostly, demon-y type shapes coming off of it. It's in the constellation Cepheus. Now, Cepheus was the wife of Cassiopeia and the father of Andromeda, all tied into this one story here. It was Cepheus's idea to sacrifice his daughter Andromeda to the sea in order to save his country that he was the mythological king of, Ethiopia, from being ravaged by the sea monster Cetus. Andromeda, and after Cepheus rescued Andromeda, they were to be married, but she was promised to, rescued by Perseus. She was promised to her father Cepheus's brother Phineus. A lot of confusing names here. Of course, a fight broke out over them both wanting to be her husband, and this resulted in Perseus brandishing the head of Medusa, who we saw the nebula for earlier, which caused both Cepheus and Andromeda to be turned to stone. So a lot of fighting, a lot of bad things amongst the Greek mythological characters here. And this one is 1,470 light years away. Moving away from things in the visible spectrum, there's a lot of really cool shapes to be seen in other parts of the spectrum. This is a shape in there's this nebula that is optically visible, the Boomerang Nebula. Overlaid of the Hubble image here is a radio image from ALMA, the Atacama Large Millimeter Submillimeter Array. And this nebula is 5,000 light years away, and the radio image overlaid here really just looks like a cute little ghost. And so this is located in the constellation Centaurus, so a little further south. The Boomerang Nebula is the coldest known object in the universe, being at minus 458 degrees Fahrenheit, or just a hair, just 1.5 degrees above absolute zero, which is actually colder than just the background radiation of space, which is at 3 Kelvin, or 3 degrees above absolute zero. And so the reason why it's so cold is that the star in the middle is sloughing off gas from its outer shell. And this gas is expanding in space in much the same way that you hopefully learned in high school chemistry, where when you expand a gas inside of a bottle, inside of a fixed volume, that it makes the gas get colder. Much the same thing is happening here. Sort of like when you use a can of air duster, or maybe even hairspray. If you spray a single continuous burst for a long time, the bottle starts to get cold. We're actually back in the visible spectrum for this one. This is sort of a very spooky image that came out of the Hubble Space Telescope that I really thought was going to be in that video that Scott showed at the beginning. This is actually part of the constellation Pleiades, not the constellation, the star cluster, the Pleiades. And it's a small bit of the reflection nebula, the cloud of dust that the Pleiades are traveling through, right next to the star Merope. And it's just such this really cool kind of ghostly structure. It almost looks like it's being sucked toward Merope, although really more of what's going on is Merope is pushing, its stellar wind is pushing the gas and changing its shape. And it's actually slowly destroying this dust cloud. And the Pleiades are in the constellation Taurus, and they are 444 light years away, so relatively close to us. But just this really kind of spooky optical light image of this little bit of the dust in the Pleiades cluster. And finally, I have to end on this fun little guy here, known as the Screaming Skull. So this is not an optical image. This is actually an X-ray image from the Chandra X-ray telescope. It's looking at the Perseus cluster of galaxies. And so these are quite far away. They're 320 million light years away. And we're looking at sort of a lot of X-ray objects that are emitting really hot light. So in this image, you don't actually see the galaxies. You're seeing the hot intragalactic gas that is being superheated up to 50 million degrees Kelvin. And that's why it's emitting this X-ray light. And the bright source at the center, next to kind of one of the skull eyes there, is actually a supermassive black hole in one of the galaxies that is spewing huge amounts of X-rays. And this image spans over 100,000 light years in the Perseus cluster of galaxies. And some of those darker areas are where the hot gas is being pushed away by other things. It's actually in the like where its mouth is the shadow of one of the galaxies that's not emitting a lot of X-rays, casting its shadow on the X-ray flux that's behind it. So really cool, lots of extreme stuff going on here, and making the face of sort of a weird, distorted, but kind of cute skull, honestly. It reminds me of the little sugar skulls for Dia de los Muertos. So with the inspiration of all of these spooky nebulae and galaxies, I want to wish you a happy Spookoween.
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 That's pretty good.
Thank you.
I like that.
Yeah.
Oh my gosh, Molly, that was
amazing.
amazing. There's so many. I never really thought about how many things there really are out there.
There was more I wanted to include, but I didn't want to talk all night. I mean, I love to talk all night, but I'm sure other people want to talk too.
No, Molly, I'm glad you included the Ghost Nebula. That one to me is the scariest one of all.
Oh, it's so creepy looking. And once I get out, you have to be in dark skies to really get those dark nebula. So maybe at some point when I'm out at the Texas Star Party or Okie-Tex or somewhere, I might give that one a go. Although my telescope's not as big as the one at Mount Lemmon, other people have imaged it as well. So I'm hoping to get some of it.
Oh, good luck. Good luck
Thanks.
to you.
Yeah, I like the witch's head. I like that. Just seems to kind of fit. We're gonna have to think next year if we do a Halloween party next year, what all we would put in there. But boy, that was a great collection of images. A lot of interesting information. Thank you so much, Molly.
You're welcome.
Appreciate it. All right, so let's now maybe we'll go to Astro Bob, and that is Bob King. Bob King fell in love with the night sky and astronomy when he was a kid growing up in Illinois, and loves to share his passion with people of all ages. He writes for Sky and Telescope's website and magazine, and maintains the Astro Bob astronomy blog, which I look at quite often. You've got some really great stuff there.
Thank you.
His book, Night Sky and the Naked Eye, and Wonders of the Night Sky You Must See Before You Die, describe the joys of sky watching, while Urban Legends of Space examines science versus pseudoscience in astronomy. Bob wants to see everything he's read about in astronomy books, with the exception of falling into a black hole. So Bob, welcome. It's so good to have you back again. I can't wait to hear your talk.
Well, thank you so much, Terry, for that nice introduction. I appreciate that. And great to be here with everybody. Good to see you all and to meet some new people too. Very nice presentation, Molly. And we'll continue on with the spooky stuff here. I've got a little presentation about black holes, which I've titled Where Matter Goes to Die. I suppose on Halloween seems like the appropriate time to talk about death by black holes. So we'll go there this evening. And I'll just bring it to the slideshow. Hopefully you can all see that. Is that visible?
Not yet.
I hear a yes.
No, you're not sharing your screen
Not
yet.
yet.
Oh, okay. Sorry. Sorry. Pardon me. My bad on that. Let's try again. How about this?
Yes.
It's
Yes.
coming. It's
called Black Hole Where Matter Goes to Die, and there's a really scary black hole.
Yeah, it's pretty scary.
off to the
Ooh,
left.
that's a creepy picture.
You got little kids watching this
You're
program, Bob.
welcome to
Come on.
put this in your collection.
Little kids.
Yeah, you're welcome to put this in your collection, Molly. We'll start with, of course, any discussion of black holes starts with where they originate. Where do these things come from anyway? And the primary source of black holes, as we'll learn here in just a second, is supergiant stars. And one of our favorite supergiant stars is Betelgeuse in the constellation of Orion, the hunter here. So Orion coming up over my house just before dawn. And Betelgeuse is one of the brightest stars in Orion, but it's variable. Sometimes it's a little brighter than Rigel, sometimes a little bit fainter than Rigel, which makes it a very interesting star to observe. But we know that it is an enormous star, what's called a supergiant, a red supergiant, and it's approximately about 900 times the size of the sun. There's our sun. It was really tough for me to make the sun 900 times smaller than Betelgeuse, but that's the best I could do, just a little dot. What's interesting about these two stars is the fact that although they are so dramatically different in size and appearance and even temperature, they both share one thing, at least one thing in common. They are both in the battle of their lives for their entire life. Within the star's core, and deep within the star, there's enough heat and pressure for the stars like Betelgeuse, the sun, all the stars to fuse elements like hydrogen into helium. And in that process of nuclear fusion, heat and energy are created. And that heat and energy pushes back against I like to call it the dumb force, just the dumb, simple-minded, single-minded force of gravity that wants to just crush that star out of existence. But the heat generated by nuclear energy within both Betelgeuse and the sun push against the force of gravity, which is why we can see the sun come up every day, the same appearance, the same size, it's not shooting back and forth and so on. So they do share that. The sun, as it evolves, will gradually lose its outer layers and it will shrink down to a white dwarf. It'll burn up its fuel and then gradually cool. Kind of a quiet way to go, so to speak. Whereas a supergiant like Betelgeuse can cook up more in its core because the temperature is hotter, the pressures are greater. So instead of just hydrogen to helium, inside Betelgeuse, it will cook up helium into carbon, carbon into neon, and those elements then into silicon and sulfur, and then silicon and sulfur serve as the fuel to create iron. Now you might think, wow, this is fantastic. Now we got a core of iron. There surely must be a lot of energy there. Unfortunately, you cannot fuse iron with anything. It just, if you try to put more energy into it, it just breaks apart. So when iron forms in the core of a supergiant, and this is likely to happen with the star Betelgeuse sometime in the distant future, basically the furnace shuts off within that star. And without the heat and the pressure from the core, what's gravity going to do? It's going to go boom, like so. It's going to want to just crush that star. And so what happens is, and I've kind of simplified it here for you, but here's our massive star. All right, it's still maintaining equilibrium like the sun and Betelgeuse. Here's the core collapse. This is what happens when the engine shuts off in the core. And this will happen with Betelgeuse. And when the engine shuts, the outer layers of the star come crashing down on the core, rebound, and just rip the star apart in an enormous explosion that we call a supernova. But there's a little something there after the dust clears, because all that pressure of all that weight crushes the core of the star to the point where the gravity of that core, of that material, becomes so immense that it just keeps on being crushed and shrinking and shrinking and shrinking until it's finally crushed so incredibly dense. You've got like 3 to 4 solar masses in the center of a star like Betelgeuse. It's now becoming crushed into an area about 20 miles across. And at that point, the gravity is so intense, it actually causes the light that's leaving its former core to bend back in on itself, to actually be pulled back in. And when it pulls in that light, when the gravity is so strong, then it becomes invisible. And we call that a black hole. So after all of the dust clears from a supernova explosion, sometimes, not always, you will have a black hole there, which is the remains of the core crushed basically out of existence, at least from our point of view in this universe. But it has effects on other stars and things that happen to stray too close. Here's a black hole. They're remarkably simple objects, really, when it comes right down to it. Here we're seeing potentially the future of the star Betelgeuse and Orion. It will crush down into what we call a singularity. That's where all of the matter basically got crunched. And that material, because gravity has kept acting on it and still is acting on it, will crush it down into a point that actually has no dimension at all. It's submicroscopic. It's infinitely dense, infinitely small point. And around it is what we call an event horizon. So this is the second part of a black hole. And the event horizon is kind of a point of no return. If you're in a spaceship out here off to one side of the black hole, and you're far enough away, you could actually orbit around it. You'd be safe. But the hole, because you're close, is gradually pulling you in. And if you allow it to pull your spaceship in, once your spaceship crosses this boundary, it's actually kind of a threshold, a point of no return. Once it crosses that boundary, it actually has to travel faster than the speed of light in order to escape going over the ledge and down into the black hole and into the singularity, uniting with the singularity. So since nothing, according to Einstein, can go faster than the speed of light, if you go there, you're going in. There's no getting back. So that's a key part of a black hole. Like I said, basically two parts: singularity in the center, where all the matter is continually being crushed to this infinitely dense point, surrounded by this invisible ring called the event horizon, the point of no return. Well, all of this mass, this incredibly dense material, just concentrated in such a small amount of space, warps the fabric of space-time. Space-time, we live in this space-time universe, which consists of 3 dimensions of space, 1 of time. Kind of makes sense in a real practical way. If somebody were to ask you, hey, let's go out to eat, you'd have 2 questions, right? First question would be where? In other words, its location in space in 3 dimensions. Second question is when? Time. Now, those 2 or 4 things really, because one has 3 dimensions, and the dimension of time together will allow you and your friend to get together at the right time and place. But if you just gave the person a time or a place, you'd never be able to get together. You need both. So space-time includes both time and the 3 dimensions of our regular existence. And it can be warped by very massive objects. We can't see it with our eyes, but we can kind of imagine it like you can picture a bowling ball sitting in the middle of a trampoline. The sun is like a bowling ball warping the fabric of space-time, and it puts a modest warp in it, and that warp is what makes the planets circle around the sun. They're following the curvature of the warpage. The black hole is so dense that it just keeps going down. I show you this because just so that you can kind of get a 3-dimensional picture of a black hole, because the previous image makes it look so 2-dimensional, just the ring and the singularity. But if you could see it in actually 4 dimensions, 3 of space, 1 of time, you would see it's something like this great warp in the fabric of space-time. Here's an attempt to illustrate that warpage and a black hole. It's a very nice animation. Black hole in the center. Here's the warpage of space, that dimple that it creates, like the bowling ball and that trampoline. And one way we can detect a black hole is if something strays close enough to it that it's captured by the gravity of the hole and it's accelerated. And as it's accelerated, it's literally torn apart by that gravity. And the material heats up because it's rubbing against other material. All this stuff gets ripped apart and it heats up and it starts to glow. And it can reach temperatures like 10 million degrees and shoot out all these X-rays and visible light and all kinds of things. And then as it goes down and crosses the event horizon, hasta la vista. That's it. Nothing's coming back. If it had an identity beforehand, right? Here's a particular star, a rogue planet, an asteroid. The identity is gone. It goes down into that hole and it becomes crushed and just totally isolated from the rest of the cosmos with no identity right down there in the blackness. Another way to detect a black hole, and this is actually how we first found them, was how their gravity affects stars near them. And also we have seen disks of bright material that a black hole will pull off a nearby companion star, because there's tons and tons of double stars out there. Binaries are very common in the universe. And when you have a binary and one of the objects is a black hole, maybe it was a supergiant at one time, it evolved, became a black hole. If they're close enough, it can draw material right from its companion, and that swirls and heats. And then before it disappears, it can radiate tremendous amounts of energy, then goes down the black hole, never to be seen again. I tried to find an earthly example of how a black hole grabs material, and this is the closest I could come with a little bit of a Halloween flavor to it. When somebody comes to your door and you offer one piece of candy and they kind of get their hand and they start raking away more material. So whether or not this works for you, but this is an earthly example, sort of black hole trick-or-treating. We have, until 2019, black holes no one ever actually observed one. There were no images of black holes that were available until the Event Horizon Telescope, which was a whole series of different telescopes spread across the planet, and altogether acted like an enormous single instrument, looked into the core of a galaxy and took the first image, not just diagrams or what we imagine a black hole to look like, but it took the first image of a black hole. And this is not exactly what it looked like, but something like this. This is the correct slide. It photographed the core of the galaxy M87. Again, many telescopes did, not exactly in a photographic way, but all of the data was put together to create this image of a very large black hole. I only talked about black holes that are of stellar mass, like a Betelgeuse-sized one, something maybe 25 miles across. But black holes can coalesce into larger black holes. They can sink into the centers of galaxies. And virtually every galaxy, modest to large galaxy that we know of, has a supermassive black hole in its core. Even the Milky Way, there's one down there that's 4 million solar masses, and it's about as wide as our solar system. Look at this one, 6.5 billion suns in the core of this galaxy, 23.6 billion miles wide. Here's our sun and the orbit of Pluto just for scale. And here you can see that dark inner part of the hole. Within this is the event horizon, and this bright light around it is material that is swirling down into the hole, light heating and giving off radiation. Now, I mentioned that black holes warp space, right? We saw that. They dimple down, they bend the fabric of space. And the more massive the object is, the greater the warpage. Well, space and time are intimately connected. If you warp space, you will also warp time. So in this example here, and the Simpsons are helping us out, we have Marge, who's away from the event horizon at a safe distance, and her clock is running. And then Homer, who's excited as all heck to get past the event horizon. Perhaps there's an infinite amount of beer beyond the event horizon. We don't know. He doesn't know yet. From Marge's point of view, as she looks towards Homer, she will see that his clock is running slower than her clock. And as Homer gets closer and closer to that event horizon, his clock and his flow of time, as she sees it, gets slower and slower and slower until he actually freezes at the event horizon. And he's there for an eternity. It looks like he's just completely stopped. However, from Homer's point of view, he's moving normally. His clock is ticking normally. And when he looks up at Marge's clock, her clock is running fast in comparison. He's deeper within this gravity well, this deep gravity field of the hole compared to Marge. This warps the space and the time. Now, this hapless person is attempting to avoid crossing the event horizon in this rather wild black hole illustration. Doesn't look like they're going to be successful. So what we're going to do is we're going to dive into a black hole. We're going to figure out that eventually they were going to lose their grip and they're going to head right in. And I'll let this repeat so that you can kind of go along and I can talk a little bit about what you're seeing. There you are, you're crossing the event horizon right there. You're looking back. And then after you look back, everything goes black. That's it. So you're crossing through. And while you're briefly alive, when you turn around inside of a black hole, once you've crossed over that event horizon and look at the outer world, remember how fast Marge's clock was going? Once you're inside the event horizon, the clock, when you look at the outer world, is spinning so incredibly fast as you're making that crossover that you're able to see for a brief moment the entire history of the universe, the entire future of what's going to happen, galaxies colliding, merging, stars dying, the whole thing, but very rapidly. And then as you face forward and you go over that horizon, it's all over. All you see is this, just utter blackness. And tell me this isn't a scary sight, just nothingness. And that's what it would look like to actually be inside a black hole. I remember I went down into an iron mine up here in northern Minnesota once, and they showed us this and that formation. And then they said, okay, we're going to turn off the lights. And when they turned off the lights, it was totally black. It wasn't like a starry night where you could still see your hand. It was pitch black, just like this. So if you want to experience black hole blackness, go on a mine tour. Of course, before you actually meet your event horizon, meet your maker, as it were, you will be pulled, stretched, and squeezed as you approach that tiny singularity. And the reason why you're being pulled is because your feet being closer to the central engine of that black hole feel its gravitational attraction that much more intensely than your head or your hand. So gradually you are drawn apart, torn apart into little tiny bits and pieces. Then your molecules are separated, your atoms are separated, and you go down I don't even know what happens after that, but all of the particles then join the singularity. Again, it's the scariest thing in the sense that there's no identity and there's no getting that matter back to the universe. It's lost to the cosmos. Now, black holes, we know, according to Stephen Hawking, can radiate energy away and eventually unravel, but it takes just trillions of years for that to happen. So it's matter, whatever goes in is there for essentially an eternity. Have you ever been in this situation where you're trying to pack a suitcase really tightly like this? I know I have done this a number of times, although I usually try to tuck things in a little bit better before I get my knees on it. I only show you this photograph because in a fun thought experiment we can turn virtually anything into a black hole. Here's the planet Earth. The Earth is a very solid thing, and the rocks seem very heavy if you pick up rocks and metal. However, there's so much space between the electrons and the protons in those atoms, and between those atoms and the next atom. There's so much space to get rid of. So if you can, like that suitcase, if you could crush the Earth, all of that matter down into something about the size of a marble, approximately, just a nice little marble, then gravity will keep on running and suck that thing into a black hole. So the Earth will be a black hole if you could crush it down to the size of a marble. And it would just be in its present position. So you might think, like my daughter thought earlier today, she said, well, won't it just suck everything into it? And the answer is no, because even though the Earth is now the size of a marble, its gravitational field is the same as it was when it was just a happy, friendly, spherical Earth, the Earth we love and know. Here's a marbleized version of the Earth. If you were to do so, shrink the Earth down to something that you couldn't even see from the moon, because a marble is what, like a centimeter across. The moon would still orbit it at the same distance and the same speed. It would be as if nothing happened. in order for a black hole to grab hold of you, Earth black hole, supermassive black hole, you have to be fairly close to it. So it's not like a vacuum cleaner where it just kind of goes around and can suck in things from millions of light years away. And that's a common misunderstanding about black holes. But they are scary enough, that's for sure. Thank you very much.
Thank you, Bob. That was really interesting. I've heard about being spaghettification, whatever.
It is
Don't
a
think I
real
wanna
physics
go there.
term. That is a real physics term.
I know Molly's right. I looked it up and I thought, okay, I've heard about it, but I didn't know it was actually used in papers now. So
Yeah, it's not just like a journal term, it's a real term.
Mhm.
Oh my
Yeah, it's a
God.
real term. So
Yeah. Not one I ever want to experience.
no, but there is Terry, there is a nice black hole experience available to you.
Oh, yeah.
Yeah. If you were to, the smaller black holes like the one that Betelgeuse could potentially make in the future, those are seriously painful because you cross the event horizon and you're close enough to the singularity that the force is so enormous that you would be ripped apart instantly and die. But the one in the center of the galaxy, being so large, you can cross that event horizon and still have some time to observe, look around you before you got close enough to the singularity to get ripped to pieces. So if we ever do send a camera across an event horizon, well, of course we can't. And once you're across the horizon, there's no waving high or getting any information back. You have to go faster than the speed of light. So
What? No
So is
selfie?
it worth it?
only, yeah, selfies just for yourself. No transmitting them, no sending them back to your friends and family.
What did you say, Scott?
I said, is it worth it?
I don't know. Would it be?
Someday
No.
somebody will explore it, I hope.
Yeah, you wouldn't have a story to tell, that's for sure.
Yeah, well, from our perspective, it would that person would sit at the edge of the event horizon and never move. That's what's so bizarre about black
It
holes.
is. Yeah.
Even though they've long gone down past the event horizon.
Yeah. That is. I mean, when you really stop and think about this, it is bizarre.
Yeah.
Trying to comprehend it. So thank you, Bob. That was amazing.
Thank you, Terry. I appreciate that.
It was, thank you. Scott, how about if we take a 10-minute break and come
Okay.
back, and we will come back with me.
All right, sounds good.
Okay, thanks.
Believe it or not, I've never actually done a black hole talk. I really ought to have one in my repertoire.
Sorry, I was just gonna move my teacup or something, but you had mentioned that you wanted to do something on black holes sometime, right?
Yeah, I feel like that's a talk I ought to have like in my repertoire.
Yeah, it's always, I've done some talks, for the public because I do community ed teaching.
Yeah.
And I mean, everybody wants to hear about black holes.
Yeah.
Because they're just so bizarre. And
There was there's a gal who's given a black hole talk at the Texas Star Party a couple of times, and I cannot remember her name, but she is actually an astrophysicist, I think, and the title of her talk is "Black Holes Don't Suck."
Yep, that's right.
You've
And that
probably seen her talk.
Yeah, it really is common for people to think, and because they have such powerful gravity, and people see illustrations of them like bathtub drains, and
Yeah.
they think I'm going down the drain. So
Yeah.
it's totally understandable that that's the impression.
Yeah, I just think it's a really clever name too.
Yep, black holes don't suck. I remember somebody said that some famous scientist, I think.
Yeah.
Like, Who was
like
it?
one of the ones that's on TV a lot, like Neil deGrasse Tyson or somebody. I don't remember.
Yeah, but it was somebody else. But anyway,
Yeah,
yeah,
it was
great title.
I know what you mean. I can't remember who it was.
So
Like
it
it was
sounds like
somebody who was on Nova sometime.
you are really cooking there in astrophysics. You're doing some stuff and doing a lot of photography too. And
Yeah, it's I've been able to do so much photography since I've got a backyard rig set up. So I've been able
yeah,
to do a lot more. And I always like looking up some details on the targets and stuff like that when I share the pictures. I actually met you at Hidden Hollow Star Party back in 2016, I think.
oh, you were there, Molly?
Yeah, I got a
Oh,
copy
yeah.
of your book.
What did we observe with the big red there or big blue?
Big Blue.
Blue.
Yeah, I think that year we had 2 clear nights that year at Hidden
Yeah.
Hollow, maybe 2.5. And yeah, I did some observing on Big Blue. In 2018, the scissor lift had a breakdown, so didn't get to observe through it that year. I've been out of state the last 2 years, and I went to Hidden Hollow again this year and got to look at Jupiter and Saturn and a globular cluster through there. So
Oh,
it's so cool.
good.
Such a great scope.
Everybody was so great. The people were so great there
That's
at
why I
Hidden
love that Star
Hollow.
Party.
And you know who came through the area here? We almost got together was Dan Everly. Do you remember? Do you know Dan from the club?
There's I'm really bad at people. I know I've met a lot of people in that club who come to Hidden Hollow.
Oh, that's no big deal. No
But I
big deal.
can't remember all their names.
He was the one that picked me up at the airport and then drove me to
Okay.
Hidden Hollow. And so of course I remember him well, but he came through Minnesota and we were going to try to get together for lunch, but then plans didn't work out. I was really looking forward to it, so maybe another time.
Oh yeah.
But
Yeah,
that
it was go ahead.
No, I'd say it was a great scope. I'll never forget the morning. I think it was Dan, maybe somebody else, woke me up at 5 a.m. Said, "Hey,
Yeah.
it's clear. You can't believe the Orion Nebula." I'd already been up like most of the night. I was just trying to get an hour of sleep, but I got up and whoa, was it nice.
Oh man.
Yeah.
Yeah. I went they held it this year, and it was a smaller crowd, of course, but we had one clear night. But yeah, I
Good.
just love that group of people. They're so much fun.
They are, and they're friendly.
They're
just
real friendly, yeah.
So are you have your degree? Are you, I mean,
Nope, still working.
you're still working. How many years left?
2.
And is that a master's or PhD?
PhD.
Gosh, that's a lot of education. I should,
Yeah.
it's what I wanted to do in college. I went to the University of Illinois. I wanted to become an astronomer, and I started out that way. But the math was too much for me to handle. And so I decided I would pick another major, and I went into something else entirely different. So
Yeah,
that's
the
great.
math, I was going to do physics as the PhD topic, but after taking another round of quantum mechanics and stuff like that, I just decided that level of math was like more than I really wanted to spend a lot of time doing. I'd rather like code up an algorithm, do that stuff instead.
Code up an algorithm. Good. Yeah, what the heck? Sure, why not?
Yeah,
Oh,
so
that's great.
yes, I moved a little more engineering direction, but I'm doing neutron cross-section measurements. So basically like neutron interaction rates with various isotopes. My main experiment is going to be on oxygen, and that's actually coming up in a couple of weeks.
Oh,
Yay.
wow. Is that in regard to supernovae?
So that's definitely one of the applications is astrophysics. So yeah, there's a lot of really neutron-rich environments out in space, especially supernova and stars. There's a lot of oxygen in some of the higher mass stars that are in their CNO cycle, and neutron stars, of course, to high neutron environment. It also has important applications for building nuclear reactors.
Oh, great. So what would you like to be doing in 5 years? Where would you like to see yourself?
Oh man, I don't know.
Wherever the job opening is, I suppose.
Yeah, I might go work for one of the national labs or something like that, because I had an internship at one of them when I was an undergrad, and it was a blast. So
Oh,
kind of
fantastic.
leaning a little more that direction.
Well, I wish you well, Molly, and I hope
Thank
you're
you.
able to get there, to that place. It's wonderful.
Yeah.
And but you also do, it sounds like for fun, you do astrophotography. So
Yeah, it keeps me sane. Well,
Yeah,
sane as,
yeah.
as one can really be, who's really into these things. But yeah, when school is stressful, astrophotography, I go process an image and it comes out of stacking, and I'm like, oh man, this is way cooler than I thought it was going to be, and get a nice image out the back and post it on social media.
That's a wonderful feeling, isn't it? To
Yeah.
get a nice image. You're producing art. And it's
Yeah.
something entirely different from the other environment you're in, the
Yes.
computational, astrophysical. What a release. Well, how nice. For me, it's like that too. I love, and part of it is you're outside too. At least I
Yeah.
am when I do astrophotography, because like Terry, I've got my camera set up on star tracking mounts and stuff.
Yeah.
So, but it
Yeah,
sounds like
and
you're doing photography through the telescope, I take it, right?
Yeah, so I've got 3 telescopes set up in the backyard. One is an 8-inch Schmidt Cassegrain, one is a 4-inch Takahashi refractor,
Oh,
and one
nice.
is and one is an 8-inch. Yeah, so the Takahashi, I really didn't think I was going to own something that nice this soon, but my uncle upgraded his Takahashi to one of the newer models and sold it to me at a nice family discount. So I was able to get one at a little more reasonable budget.
Well, you'll have that instrument. I mean, if you desire, you'll have it all your life. And
Yeah, it's phenomenal.
Yeah.
I've gotten some really good images out of it. And the third thing I have is an 8-inch f4 Newtonian that I use for doing my variable star observations.
That is cool. Did you know that I'm also a member of the AAVSO? I've
How
been
are
a member
you?
Since 82.
Oh wow, that's awesome.
Yeah, long. And yeah, it's a wonderful organization. You must submit observations then?
I do.
Magnitude estimates?
Yeah, I actually have a set of photometric filters that were given to me by a
There you
member
go.
of the Dayton Club, who didn't actually know what they were. I posted them on cloudy nights, like, hey, does anybody know what these are? And looking at the symbols on the side, I couldn't quite tell what it was. And someone was like, those are photometric filters. I'll buy them off you. I'm like, ooh, I might find a use for these.
Super good. So when you submit data, then are you using V magnitudes or all different kinds?
I do 4. I do V, B, I, and R. And actually I have a CCD camera, so I can do all the transformations and are linear and stuff like that. So yeah, so I only have 4 out of the 5, but they're Johnson Cousins photometric filters. So I submit in their actual bands.
Just a quick question. What's a favorite variable?
What comes to mind when you think of Halloween? Trick-or-treating, jack-o'-lanterns,
Tabby Star.
ghouls and goblins? But the sun? Probably not. But just 5 years ago, in the week surrounding Halloween, the sun sent us some tricks and treats of its own. The tricks were a series of some of the most powerful solar storms ever measured. Storms that disrupted power grids, communication lines, and satellites. But the treats were some extraordinary auroras, seen as far south as Florida and Texas.
The effects of these storms on the Earth were ghoulish enough that we had to reroute aircraft. It affected satellite systems and communications, actually caused a power outage in Sweden for about an hour. But I think generally the public was very excited to see the ghostly aurora that were created in the night sky. The aurora are normally limited to higher latitudes, and so these storms were so powerful that they created aurora that could be seen as far south as Florida. So you can imagine seeing these ghostly figures haunting the night sky.
In all, nearly 17 major flares erupted on the sun during those 2 weeks in 2003. The result of energy building up in the sun's magnetic field lines until they became strained enough to suddenly snap like an overstretched rubber band. The results were coronal mass ejections, the largest explosions in the solar system, able to launch up to 10 billion tons of electrified gas into space, and cause some of the ghoulish effects we felt here on Earth. These storms were also eerie because they came at such a surprising time.
These storms were spooky because of the timing of which they occurred. That is to say that it didn't occur in a stage where most of the activity occurs. In fact, it occurred about 3.5 years after solar maximum occurred, so it was spooky in that respect. And it was also spooky in the intensity of the storms. These were some of the largest storms ever observed.
So can we expect to see any ghostly-looking auroras in the night sky this Halloween?
Well, I don't think we're going to see repeat this Halloween on the 5-year anniversary because we're at a time where there are very little active regions on the sun. However, we are going to be ascending to a greater period of solar activity. So, we may see some large storms in the next few years.
Still think the sun isn't so scary? Hopefully this spooky tale will make you think again.
You're muted.
You're muted, Scott. Welcome back, everyone.
Welcome back, everybody.
I got you, Scott. I got you.
What's so scary is that you see my lips moving, nothing's coming out. Okay, so
Imagine, if you will.
up next here is Terry Mann, and I think that the subject of Aurora is quite appropriate. So, Terry?
Thank you very much, Scott. Let me get ready to share here. Oops, hang on just a minute. I actually shut it after the other one. Yeah, that video is good. I will have some pictures here. I know I at least have one from 2003. And sorry, let me start over again and see if I can't get, yeah, there we go.
It's the ghost in the machine.
It is. It definitely is. And this is going to take just a minute probably to go where I want it to go. But yeah, Aurora this time of the year just seems like something, well, it's something because it's one of my favorite things to watch, one of my favorite things to chase. This time of year, it just seems perfect for me. So my talk is Aurora, the soul of the night. And what I want to do, I don't really want to go into all the mechanics of what the aurora is. We've all, heard quite a bit about that, and it's pretty easy to find. What I would like to do is look at the imaging end and some of the things that I have learned over the years that I have imaged it. One of the things that I do want to bring up is we are coming out of solar max. They're saying now we should be in our maximum bit of solar activity between 2024 and 2025. So if seeing the aurora is something that's really been on your bucket list, and we have so many people that have turned to astronomy through the COVID situation, and people that are watching the sky, and I've talked to quite a few that said, wow, I would just love to see this. This would be the time, I would say, that you need to consider doing this. Hopefully from now until 2025 or even beyond, and definitely beyond, hopefully we will see more aurora. This fall has been very active. Some of the aurora that I've been watching online has been incredible, and the pictures I've seen have been incredible. So if this is on your bucket list, stop and give it some thought about what you might want to do to try to see it, because you might have a better chance. The more active the sun is, the better off we all are if we want to see aurora. One of the first things I always knew to do was, if I was going to go somewhere and see the aurora, there also had to be something else for me to do, because there's clouds. And there are times just like this night that I was sitting in Alaska. Conditions are absolutely perfect. Everything is perfect, crystal clear sky, and there is no aurora anywhere to be found. This happens. You cannot really predict the aurora. You can get a feeling of, okay, we've got a really good chance, or yeah, it looks like we really might see it. think of how many times you have heard on the news or read in the paper, tonight there is going to be aurora everywhere, up north. I have seen that a few times, and a couple times I chased to Upper Michigan. And when I got there, you know what I saw? Nothing. It cannot be exact science. It just is not. So always have something else that you can do. Because this will happen. It's part of chasing aurora and seeing it. It's part of the beauty of aurora, because you do still have clear skies a lot of the times. Now, imaging, honestly, imaging is easy. It really depends on what you want to do. I mean, on space weather last week or the week before, there were cell phone pictures that were unbelievable of the aurora. And what you are going to see here that I've taken are simple camera and tripod. There is nothing really fancy. Where the expense gets in is, do you want to buy a higher end camera that can handle higher ISO and faster lenses, wide angle lenses that are faster? And so it just really depends on what you want to do. This picture was taken with a simple camera and tripod. I shoot with Canons. Right now I have a 6D and a 5D Mark III. And I would love to upgrade my cameras if they would get cameras in stock that I would like to upgrade to. And the Sony A7S. I still have a first generation because I waited too long to get the 3. And now I'm just, I'm sitting back waiting on equipment that might be available before I go back to Alaska. I use fast lenses. That's the one thing. I use a camera that can handle higher ISOs, but I use fast wide angle lenses. Most of them are an f1.4 or 1.8. And I use a Nikon. I have a Nikon 14-24 that I put on my Canon camera that does a good job, but it's a 2.8. And for aurora, sometimes when it's not really bright and active, but just kind of hanging up there, it makes it a lot harder to get the kind of pictures that I really would like to get. Honestly, my favorite lens is a 20mm f1.8, and I do use that a lot. It just seems to be a nice balance for me. But whatever you can start with whatever you have, and that's the whole point, until you get the hang of it, or you feel like you really want to invest more money in this. And it's kind of like astronomy. You can start out with a 3-inch telescope, a 6-inch reflector, and before long, you're wanting the bigger and bigger and bigger. And it's the same way with camera equipment, whether it's CCD that you're going to put on a telescope, or whether it's a DSLR, however you're going to do it, your equipment eventually makes you want to spend more money. I mean, that's just the nature, I think, of astronomy. Once you get used to what you have, you want to do a little bit more to maybe reach a little farther. And again, this is just camera and tripod. I like to shoot on the right. I was in Alaska, and I went to the Arctic Circle with a group of people, and we were on the Dalton, and we hit a blizzard. We hit an unbelievable blizzard. And it broke the blizzard. Finally, on our way back, we got into clear skies. And just for about 45 minutes, when the skies opened up, the aurora lit up everything. I mean, everything lit up. It was one of the most beautiful pictures and visions I even had while I was standing there. The Yukon River was just down below us, and we were up on a hill, and it was just absolutely beautiful. And I like to shoot that way, where you can see down to the horizon. I always like that. But here I'm at North Pole in Alaska, and it was over the trees. And that night it was so active. I ended up doing time lapse, and I just really like that. And you can see here the Big Dipper right here in the center. In Alaska, it's pretty high in the sky. And this was the first time that I ever shot in 40 below zero. And it was probably either the first or second time I was in Alaska. And the first thing you can see here is the aurora that I'm trying to image is dim. It really was dim. This is probably about a 30-second picture. And you can tell that because it's a blur. And this is not what I really like to see, but sometimes if you want to get the picture, that is what you will get, because the aurora is not always active. It doesn't always just lively dance around the sky. Sometimes it's just a green color in the sky that barely moves. And sometimes when it does brighten up, it takes it a while to get bright. As you can see in the middle, I had taken a long enough exposure where the green had kind of turned to a lighter green. It was beginning to get active, or I had shot the picture long enough that the more active part showed up. But it is just something you have to find a balance, and you can't always do that, because with aurora, it's either moving fast, moving slow, or it starts slow, then it moves fast, then it can really mellow out to a dim green, then all of a sudden it can brighten. It's a guessing game. You do the best you can do with that. But this night at 40 below zero, and this is a film shot. I had, I think, 3 camera bodies with me. And seriously, every 2 or 3 pictures, my shutter was freezing. I was working with a straight, film camera. And I actually turned around one time and I had the remote in my hand. And as I turned around, the wire just snapped in two. I've never had that happen before or since, but it just snapped right in two. So you kind of have to be ready for whatever weather that you happen to be in. Things like that can happen. So why did I call this the soul of the night? Well, this picture was what made me call it the soul of the night. This is my backyard in Ohio. And I believe this was either the 2003, or it was probably one of the 2003. I had woke up at 3 o'clock in the morning to get ready to go to work. And I had a satellite dish at that time, and I turned on the TV and everything was real staticky. And I thought, wow, they said something about maybe we could see the aurora that night here. And I went out in my backyard and I couldn't see it as clearly as what it is here, but I could see the reds. I could definitely see some greens. But I was taking pictures, got the camera going, and then I just kind of kicked back and just watched. And all of a sudden, I noticed this white wave that was within the aurora. And I had never seen pulsating aurora before in my life. And if you have or haven't seen it, watch for it, because it's not that rare, I guess, but for me, it was very rare. And I've only seen it a couple times in Alaska, but it has a flow to it. And it's like a heartbeat. And it was, the longer I stood there and watched it, I could time it perfectly. It just flowed. And I thought, wow, it's like the sky has a heart. And from that, I thought, yeah, I can see that's the soul of the night. And that is how I see the aurora. It's, some people see rivers of light. And I get that too, because when it's really active, it does look like rivers of light. To me, I always remember that pulsation. And like I said, I've seen it about 3 or 4 times. And it just seems like it is something, it seems like the sky is alive, because it's moving and it has kind of a rhythm to it. And it was just amazing to me to kind of put that together. But, that's how I looked at it. But this shows it can be seen lower than usual. Very honestly, in Ohio, I don't think I've seen it here since 2011, and it was a very dim, more or less a photographic aurora. This I could see naked eye. And this is more pictures. And I believe this was, I don't know if this was 2003, but I'm thinking it is. This is looking south. And Mars was in the aurora when I shot that night. So it was looking south and I had red. And this, when I walked outside, I could see this green. And this green looked like a sparkly icicle, a sparkly green icicle is the only thing I can think of. You could tell it was there. It almost seemed to flash, and I'm sure it was the motion of the aurora. I couldn't see the red. This is a 30-second at least exposure right here. And so I couldn't really see the red as much as what the camera did, but it was amazing. And a lot of people still look at these pictures and say, I can't believe you saw that in Ohio. Believe me, this is my backyard when we actually had a huge CME or series of CMEs that were happening. And these are film, again, camera and tripod. Now, one of the first things I did when I went to Alaska was I'd never done time lapse. So what I did was I learned how to shoot time lapse and then figured out how to put it together when I got back home. And so this was my very first time lapse in Alaska. Watch the ground on the left-hand side. It was amazing what it would do. It became so active. And you can see right there, the ground just lights up. And you can see there's pictures all around, people all around taking pictures. But it just blew up. And when it does that, the ground will turn colors. At one point, I had walked into my room and I had a big north-facing window, and it was like somebody had just shot a flash on a camera. And I knew whatever the aurora had, just fired up at that time. And my whole room lit up. It was amazing.
Can you play that one more time?
Yeah.
Here we go.
Yeah, watch the ground.
Oh my God.
Yeah, and that happens a lot. When you get an active display and you have snow on the ground, that happens quite a bit. And it turns the ground green just for a few minutes. And it can turn, I think I've even seen it go a slightly red before too. But for me, that was amazing. That was my first actual motion of the aurora. And so you can do that with the simplest camera and tripod and just make your own movie that way. You do not need to have a high-end video to do that. So you can create your own thing there too. Now, air glow. A lot of people confuse air glow for aurora. And this is in the UP in Minnesota. And they have a lot of air glow. I think Bob can probably talk to that too. I've seen the reds, I've seen the green. But again, and this I could see naked eye when I was standing there. So a lot of times when there is air glow, I've had people say, is that aurora? And it does not, it looks green and the aurora can be green, but there is a difference in what you see and how it moves. And so that's something, I like air glow. I mean, I think that's beautiful too. It has its own place, I think.
Look at that. Look at all the diamonds on that mirror-like surface.
I know.
Of the lake. It's incredible.
It's funny. I've said the same thing. A lot of times I've been in such super dark skies, it's like they're diamonds hanging in the sky. And that's kind of the way I talk about it too, because in the water, the reflections were just amazing. That was such a still lake. And I couldn't even tell you there's so many lakes up there, what it was, but it was an incredible area. And the sky glow was just unbelievable. Air glow was just unbelievable.
Composition, the capture, everything about that is really amazing.
I love to shoot where there's water. I love the reflection because it is so cool to see the stars when you also see the land, how the land is. And actually, this is lightning. That little bit of pink there is lightning. There was a storm building over there, but this was way out in the middle of nowhere. But yeah, so air glow is really cool too.
Very cool.
Now, this will be a little confusing. With the aurora, a lot of times when you're imaging, you have no idea what you're going to have until you get home and you can see the pictures that you have taken. And if you look really close, do you see the eye, another eye, a nose, and he's yelling or she's yelling, whichever. Yeah. And you can tell this is the ground.
Oh.
Yeah, this is the ground.
That's scary, Terry. Come on.
Scary,
Yeah,
Terry.
that's
Thank
freaky
you.
looking. Whoa.
There's little children watching this program, okay?
Well, I'll make them feel better. Well, I don't know, maybe it won't. 2
They're
minutes
gonna have
later.
nightmares.
2 minutes later, it uprighted somehow.
Wow.
This is a ski lodge on Clary Summit. And then here it is again, and you see the eye, the nose, the mouth. I call this north wind because he or she is facing north. And as you can see, the aurora was incredible that night. But when you're imaging this, you don't see any of this. It is moving so fast and so many different directions and different brightnesses. You never know what you have. And so it's like a Christmas gift. Every time I shoot one night, I start going through the images. I never know what I'm going to find, but I'm always surprised. And more shapes. I found the arrow pointing at the cabin. I sure didn't see that either. And then this looks like a hand. to me. It just looks like a hand reaching down. When it is active like that, again, you can see the reds.
Cool.
Yeah, reds in there. And this is where it was getting brighter, where you have the arrow pointing down at the cabin. But it is amazing. You know, I've heard a few people say, you know, I've seen the aurora. Yeah, it's cool, but I've seen it once. I don't need to see it again. I could watch the aurora every night if I could, because it's always different shapes, different motions, different intensity. Everything is amazing. The whole sky dances. It is just incredible. But one of the coolest things to do is if you shoot in the mornings before the sunrise or sunset, you get these reds and you get the purples and you get so much more color because your sky is not completely dark yet. It has the blue tint to it. And so different colors seem to show up. And so these are, you know, with the Milky Way, and you can see clouds, but this was right after sunset. And this was at Denali. I was there for a few days and trying to get some pictures there.
That is
and it really just is amazing. And you can see some structure with this. And honestly, that is what I try to do. I want structure in the aurora. I don't want blurs. I want to be able to see the streams if I can. You can see a little bit here. So this one I was able because it was bright. But again, then you have that intensity. It's bright up here, but it's dim up there. It's so hard to judge. You just do the best you can and just keep shooting picture after picture and adjust. And this is one of my favorites. Can you tell? This is where the sun set down here in the orange. And look at these colors. Look at the reds. Look, I mean, in the blue.
It's very subtle, but it's beautiful.
It is. And
it's like, it's one of those images where you can hear like symphonic sounds, you know, like these are notes. Very beautiful.
Yeah. Yeah. And that's something, you know, there are people that say they have heard the aurora, which I never have. They have never been able to prove that, but there are definitely people out there, I think, that are still trying to. And that would be interesting to know if by some way they could hear aurora. I don't know, but yeah, I tell you, there is nothing like every night when I am someplace where there will be aurora, before it gets dark, I am set up and ready to go, because you never know, it might already be happening in the daylight, you know, that you cannot see it yet. And as soon as that sky starts darkening, just like this evening, all of the colors start up and the Milky Way. And it is just amazing to watch. And again, there was a yurt, and just, you can see sunset, sun had just set, and still some of the reds, a little bit of structure to it, but not much. It was just actually starting up. And then you get to the night, and when you actually have aurora going. Now the picture on the left, again, I'm in the UP of Minnesota, and I'm on a big lake again. And we knew there was going to be aurora, but we didn't know how much. And it was one of the most amazing nights in August to be up there. And it just, the reflection in the water, again, a very, very smooth lake, was just incredible. And here, Big Dipper right there. You have the Big Dipper there.
Look at that.
Yeah, it's
beautiful. Again, though, the mirror-like finish of the lake reflecting all of the cosmos with the aurora. It's incredible. What a beautiful place to take, you know, you can't imagine another planet to go and take astrophotography from. It would be Earth.
Yeah. Yeah. And I tell you, upper Minnesota in the UP, my gosh, there's so many lakes up there. And a lot of them are just crystal glass clear. They are smooth. And when the stars come out or the aurora starts up, it is incredible to see that reflection. And this one again is right outside of Fairbanks. Actually, that is Fairbanks light pollution that you see back there. And there's times, you know, in Alaska in the wintertime, it just looks like a winter wonderland. And the aurora, this was probably a couple hours after sunset, but you can see the reds. And it came out so beautiful. And with, Fairbanks in the background, it was just something that I liked real well. This night, this was on the left. I had the light, the aurora was like it poured out of one point in the sky and then fanned out. It was incredible to watch. It was so, so active. Again, with the reds, I was fortunate enough not to totally burn out all of the green on the bottom, because up where you see greens at, it's not as intense as where it's really light green here. That's where you start to maybe possibly burn out. And I was lucky enough to get the structure of, the shapes of everything going on. And again, it is just a trade-off. And I believe I had this picture on there before. I didn't realize that, but that is the one through the trees with.
Breathtaking. I mean, these two examples right here, this prismatic effect of this aurora stretching across the sky, diagonally across the sky, and then this thing kind of hugging the trees, cradling it, with this beautiful light, it's incredible.
Yeah, I ended up doing a time lapse with this and like I said, normally I don't shoot it through the trees. I like seeing the whole thing if I can. But I did a time lapse, and it was amazing how fast it was moving through the trees. And you can see there's more motion here. Over here, you have like the blah green aurora, but over here, there was a whole lot of motion, and it was moving. And in so many pictures, you have that.
Yeah.
Yeah, you have more quiet aurora to one side, and sometimes very, very active aurora to the other. So again, it's a trade-off of what you can think you can get and what really looks the best for what you're trying to shoot. And this is coronal aurora. And I got to tell you, this is what I really like this. And it's tough because this is straight up. This is all three in Alaska. This is straight up. If you were looking for the Big Dipper's right here on this one, and it's in the middle just about of these two. And so you have no foreground. You have nothing to compare it to. But that is when everything can be so active and alive and dance clear across the sky. And the colors, as you can see, the colors are amazing when you have multiple CMEs or a very large CME hit. It is just incredible. So that is something, when it does that, very honestly, when I'm in Alaska, there's snow on the ground and I am dressed like, you wouldn't believe how I'm dressed. You wouldn't even know me. I just more or less fall back and just lay on the snow and watch, because I let the cameras run and I watch. It is incredible.
Wow.
So what I'm going to do now, this is with my A7S, and I'm going to buzz through some parts here because parts of it will be slow. This is real time. This will be real time as soon as I can get this back. And as you can see, the Big Dipper. What you're going to see is some of this starting up. I'm going to let it at least get a good start. And I don't know how bright that is for you, but it will brighten up here in a minute.
It looks fine. Looks
okay.
good.
You can see the detail?
Yeah.
Okay. It starts slow. I'm going to see if I can get it going here just a little bit faster. Okay. It shows the motion. But what's going to happen is you're going to see coronal aurora actually happen. And then you can maybe understand how those pictures came to be. I don't know if it's moving.
You haven't hit play yet.
There we go.
There we go.
Yeah.
Oh, that's beautiful.
Yeah.
Wow.
This is in real time?
This is real time. And that's what I mean. If you are not looking up when this happens, you can easily miss it.
Look at this.
Holy cow. Did
Yeah.
it appear that
How could you
bright?
miss this?
Yes. Now, this is shot at 25,000
Okay.
ISO
Okay.
with the Sony A7S unmodified. So, but you see how you can get the pictures of the corona in there, the coronal, and see how it spins around in the color. That is exactly what it looks like. And this was an active night. I shot video and images practically the whole night. And that's one thing. Thank you. When you do this, if you really want to see aurora, you have to turn into a third shift worker. I mean, you can start up cameras and let them run, but I want to see what's going on. I like seeing what is up there. I didn't come there to sleep and let my cameras see all the good stuff. That is part of it. You know, when you're there, doesn't that look like a comet?
Does.
When you are there, it is just incredible. And if I had the sound on, you would hear people screaming and yelling. It was just.
I'm screaming and yelling on the inside, Terry.
Yeah, there's times when I sit back and watch this. I do too. See the structure. That's what I'm after. I want to see the streamers. I want to see this in the pictures and look at the color. I mean, and then it dissipates so fast sometimes. And you go from completely green skies to black very quickly. And it's just amazing when the sky is active, when it's a nice big CME. If you get a KP6 up there, it's on fire. The whole sky's on fire. Let me run through a little bit farther. But anyway, that's what I mean when I say coronal. It is just incredible to watch. And the colors. It is just something else to see this.
Terry, how does this change you by seeing all of this in the sky? I mean, you've made many of these trips. You've gone out deep into the wilderness. You do a lot of this stuff alone. I mean, what has happened to your psyche, your heart, your soul, whatever? Okay.
To me, honestly, it is kind of a spiritual, humbling thing, because there's times I feel, there's times I'm out there and it is so incredible to be under a completely dark sky with stars that look like diamonds. And I can stand there with nobody else around and just soak that up.
Wow.
To image the Milky Way, to do the stars, no matter what I'm doing, there is a connection, I think. When you start paying attention to the world around you, no matter what it is, you make a connection to nature. I mean, and to image something like this is not like putting, and I love putting a camera on a telescope and imaging.
Sure.
But with this, you have to work with nature's laws. You can't pose this picture. You have not got time to say, okay, I need this many images, I got to do this. You have to react to aurora instantly, because if you don't, you're going to miss it altogether. And so you kind of work on nature's time and how everything is running, in the sky. So for me, I think I'm more connected to nature than I love my sister to death. My sister likes the big cities, she likes to do things like that. And that's perfectly fine. I do too.
That's where all the restaurants are, but.
Oh yeah, you got to eat. But to go out and to actually
this feeds the soul. This feeds the heart. This feeds the psyche.
Thank you. Right. Yeah, and there are people that understand that, and there's other people that probably think I'm crazy, but it does.
Okay.
Just as people do, like Molly was saying, it keeps her sane to do astrophotography. Yep. It's the same type of thing. It gets you focused and it takes you away from everything else, and you just really admire what is right there in front of you. And you didn't even have to pay for that. That sky is there every night.
Yeah, it's sacred. It's sacred.
It is. And it's something families enjoy so much. Yeah. And I think that's been the way it has been since COVID. Everybody has gotten out and started camping, and you notice the stars more. And you see something like that, and it's just, you're awestruck. I'm sorry, you're awestruck.
Oh yeah.
I remember I had a bench there, and I laid on that bench, I don't know how long, and just watched this. So that is what Corona is. And you can see how it happens, because it always spins around colorful, fast. It is something amazing to see. I would recommend seeing that anytime you can do it. It is incredible. And when I'm in Alaska, and I can't say that when I'm home. This is the camera I watch. This is an Aurora camera. All the information is right here. And I'm going to start this up. This is what it looked like last night at Poker Flat Research Range. I'm going to get it down to the dark. So you can watch whether you're in Alaska or at home. you can see what's going on with the cameras there. And this is on when it's dark, and it's only on, I believe, in the winter months for Poker Flat. I'm gonna get past, and you can see clouds. I don't know about everybody else. I have really fought clouds in any imaging I'm doing this year. It has been pretty tough. And when I'm in Alaska, as I said, I watch this and understand too, this is a camera. So it might look this bright. And this was last night at Fairbanks. It might be this bright on this camera. When you walk outside to your naked eye, it will not be that bright. These are longer exposures, but look at the reds, look at the curtains. I mean, the motion there, you see exactly what I'm talking about. You see the bright white aurora down here that burns out, but yet you have the green up here. It's, but that was at Fairbanks last night. I mean, I wish I would have been there last night. It's incredible, but you can watch this at any time. That is the web address for it. The University of Alaska Fairbanks runs this camera, and Poker Flat had an open house a few years ago, and I was so fortunate to be in Alaska at the time, and we got to tour everything, and I got to see LiDAR working, which was really cool. But I also saw where this camera was set up, and it's just an amazing place. That Fairbanks in general, I think, is an amazing place, especially in the winter. I think I've been to Fairbanks one time in the summer, and it's funny, it wasn't the same as in the winter. I like it a lot better when the aurora is out. And I can't leave without giving you my ghost aurora. This one is film. These are huge, huge pine trees on top of a hill. Whoops. It is amazing what you can see. There we go. And I could not see this forming, but when I looked at it, do you see my ghost with the arms up?
Yes.
And its eyes right here. This is my aurora ghost. So happy Halloween, everybody. Enjoy it at the end of the month. And thank you for watching. And there we go. Quit sharing.
Yeah. Beatrice Hines comments, she says, I've been laughed at about from people that I told them that I love the stars, but I'm glad we're all here crazy.
Hey, I'm right with you. Me too.
Beatrice has another question. She wants to know what kind of lenses you like to use. Is it a brand? Are there certain lens types?
I have a variety. Like I said, every once in a while, I buy Nikon lenses and put them on my Canon camera.
Canon, okay.
Yeah. I have a couple that I do that.
And I know that Molly likes to use a Minolta. Molly, which lens is it? A 135?
I have the Rokinon / Samyang 135.
Rokinon. Okay, yeah, Rokinon used to make lenses for Minolta exclusively for a while. Okay. That was back in the days before you were born, so. Yes.
Yeah, and I use those too. Actually, I have the 135, and that is the 20 millimeter one I use is the Rokinon.
Yeah, I really want their 14 millimeter.
I've got that too. Yeah,
I want it.
Yeah, they make a good lens that is not so expensive. There are other really great lenses out there, but yeah, and I've got the Nikon 14 to 24. If it's an f2.8, and that's a little bit slow for what I want to do with aurora, unless it's super bright. But yeah, and I would like to upgrade my camera if I get to a point where they actually have some in stock.
Yeah.
Nice stuff, Terry.
Thank you, Bob. Appreciate it.
It's great. Yeah, I love I've seen all those different forms of aurora here in Duluth over the years, and the coronal stuff that you captured exactly matches what my impressions were too. And also that arc that shoots through the northern lights sometimes, just incredible.
Yeah, it is. And I just bought, I got a Canon RA, and it's modified, and I can't wait to get that up in Alaska. I've been using that for my deep sky. I've been using that like on Heart and Soul, along with the extreme filter. But yeah, so, there's a lot you can do with it. And believe me, it isn't once you see it, it's all the same. Every time you see it, it's different. and it's just as beautiful.
I love them. Yeah, I love the set. To me, I stick around and I just watch it as they change. You kind of take what nature gives you, and each one is unique. And
It is, yeah.
it's
yeah,
a wonderful experience.
I think people that have seen it as active is what some of us have. It is. It's amazing. I mean, the whole sky just dances, and it is truly amazing. So,
I bet you've just one quick thing. I bet you've shouted out loud at least a couple of times when you've seen some of those things, because it's involuntary. Sometimes that's the reaction. You can't help it.
When I run my videos, I have to shut the sound off.
Yeah.
You can really go, oh my God. Yes, I shut
cool.
the sound. Yeah, I'm sure you've experienced the same thing.
Oh yeah, it's just like somebody squeezes it out of you. You're like, you just have to react, you know?
Oh yeah. The first time I saw Coronal Aurora, I swear you'd have to pick my jaw up off the ground. I was so amazed. But anyway, well, thank you, everybody. Next up is John Goss. Now, what could we say about John Goss? I can say a lot about John. The announcements that you see for the league, for a lot of the things we do, John Goss is our media guy. He is amazing when it comes to designing announcements, designing anything that we need, pins, everything we do. I say, John, have you got a little bit that maybe you can help, do this? John, the league would be lost without John and all the work he's done. He is a past president. He has held so many different offices. He knows how to do everything. How about that, John? Great all-around guy. Thank you. And he is also the master of lunacy. And that was a secret until now.
Yes.
So, John.
Well, we've been saying it all week long.
I know. That will stick, John. So I will turn it over to you, Master of Lunacy.
All righty. Well, thank you, Terry. Let me describe what's going on here. I think that didn't work for whatever reason. Okay, about 2 years ago, in the lead up to the 50th anniversary of Apollo 11, we were producing a trivia question each day for the moon. So I ended up with about 300 of these things, and I've kind of culled them down tonight to pick out some of the more different ones, the more interesting ones. And I'd like to go through some of these with you right now. I think I have 24 of these, and people have asked me, well, how did you come up with 300 questions? Well, what I did is just divided it into different categories, like art and culture. We've all seen the movie 2001: Space Odyssey. Well, there are a number of questions you can ask from that movie. There are various paintings from famous artists. You can ask questions about that. You can ask questions about the physical nature of the moon. How far away is the moon? Well, you can ask that a number of different ways. How far away is it? Okay. But you can also ask, how long does it take to drive a car there? How long does it take light to go from the moon to the earth, earth to the moon, whatever? Things of that nature. So I was able to come up with a number of questions. So I'm going to go through with some of these right now. Starting out with a little poem here, since this is about lunacy. With a big bright moon a-shining, astronomers are a-whining. Mons Pico at sunrise, Lunar X gives a surprise. Night's mysteries are aligning. So that's what we're going into right now. Have a question for you. What is wrong with this scene here? I pulled this off the web, off a reputable website. This wasn't some crazy thing. It was probably a news organization that released this. So how can you tell that this is not Buzz Aldrin descending the Apollo 11 lunar module? Well, one question you keep asking about the moon is the physical relationship between the Earth and the moon, where the Earth is in the lunar sky. Well, the moon from Apollo 11 landing site is never, the Earth from the Apollo 11 landing site is never near the horizon. It's pretty much straight overhead, very high in the lunar sky. So if somebody inserted that Earth, I don't know why. So that's the correct answer. Next one. You know, I had a number of questions about the Apollo program since that's what the whole thing was about. I found this kind of interesting. You know, how much did the lunar rover weigh? We all like seeing it zip across the lunar surface. You think it's probably pretty heavy just by the size of it, but well, not really. It was only about 450 pounds on Earth. Of course, on the moon, being 1/6 the gravity, it drops it down to less than 80 pounds. So, you know, you could lift it up and scoot it out of a rut if you had to. Well, I guess most people could. This is always an interesting question. You know, we've all heard and seen the big moon illusion. When the moon is fairly close to the horizon, it seems to be fairly large. Wait an hour or so later, when it's higher, it's quite a bit smaller, at least you think. So what's the cause of this? And I have read a number of accounts. You know, when the moon is close to the horizon, it can be compared to the size of an object on the horizon, so it seems a little larger. But from what I have really read about this, it's kind of A, but it's more C. It's an unconscious psychological effect. Because it occurs over the ocean, it occurs over a desert where there are very few features that you can compare this to, but you still see it. This is one of my favorite ones because it's what I say isn't really what is true, what I'm going to tell you. Why has it been said that the moon is made of green cheese? Okay. Well, obviously mice are extra active during the full moon. I don't know. But the answer really is C. The green isn't referring to the color. It's referring to an uncured state of recently formed cheese. A cheese wheel's appearance in a reflected pond or pool seems to resemble that of the full moon. Now, no one really knows the answer to this, but this seems to be a plausible explanation of how it came about, because obviously no one really believes it's made of green cheese. This is one of my art and culture type questions. I think we've all seen this at some point in our lives, the Moon Over Half Dome by Stewart-Adams. So question is, where did it first appear? On the cover of National Geographic? Well, could be. In a drawing by Norman Rockwell for the Saturday Evening Post. This is right up his alley. And C, on his son's wedding announcement. Well, of course, you picked the oddest one there. It was on his son's wedding announcement. That's where it was first published. So can you imagine having a copy of that right now?
Pretty nice.
Yeah. So amateur astronomers are always looking at sky scenes and determining their astronomical accuracy. You know, this is art. You can draw anything you want. But, you know, with this scene of clouds over a country stream, highly stylized, you know, what would really drive an amateur astronomer up the wall on this scene? Because it's not really correct. Well, you know, you got your crescent moon with a star in the center of it. You know, that's physically impossible, of course.
Right.
But you see stuff like this now and then, especially in Sunday morning comic strips in the paper. They often have depictions like this, and sometimes it's kind of funny. Another art and culture question. If you like watching murder mysteries on TV, oftentimes they will have the moon in the background as a murder is about or has just happened to take place. So how can you use that full moon as a clock to determine when this murder is taking place? So on this picture with the moon, I guess I have it pointed kind of straight up and down, north and south is straight up and down on the moon. So would this be taken at, or would this crime occurred as evening darkness fell? Would it be occurred around midnight, or would it really no way of really knowing? Well, it's at midnight, because at midnight, the north-south axis of the moon is pointing straight up and down. Closer to sunrise or sunset, the axis would be much more tilted. Excuse me about my voice. Earth's shadow. What's going on here? Well, the moon darkens during a total lunar eclipse, which I noticed we had a question here earlier tonight about the upcoming eclipse in November. What's the cause of the darkness on the night portion of the crescent moon? Is it the Earth's shadow? Is it the moon's shadow? Or is it a perpetual night on the moon's far side, which is not really the same as its dark side? Well, it's the moon's shadow. It's the same as on the Earth. You're standing, the sun goes below the horizon, things get dark out. Well, you're standing in the Earth's shadow. You just happen to be within the first 5 feet of it. While during a lunar eclipse, the moon is 240,000 miles away from it. So it's the same shadow. But for the crescent moon, the night side of the moon, it's the moon's shadow. Then I started talking about some of the physical features on the moon that you can see. The crater Plochus is really interesting to see because it has a fan-shaped spray coming out from the spray. Kind of goes to the lower left from the crater in this picture. Well, what causes that? Is it an asteroid impacting the lunar surface at a low angle? Is it a volcano that explosively disrupted? Or something else that we haven't been able to quite figure out? Well, it is believed to be occurred during the impact from an asteroid at a low angle, causing a spray like that. You see it in some other craters on the moon also. What makes a valley? Now, we have lots of valleys on Earth. Well, the longest valley on the moon is 246 miles long, but it's unlike anything that's on Earth. How was it formed? Was it formed from ancient glaciers? You know, some people really believe that. Is it really a giant crack in the lunar surface, or was it formed by a combined excavation of a line of meteor strikes? Well, I think we can all guess that one. It has to be C. It was all from meteor impacts. Perhaps there were several of them coming right in a row that hit the surface at just about the same time, carving out a linear, well, almost linear crater. It was one of the more oddball questions. At what temperature does water boil on the moon? At Earth, water boils at 212 Fahrenheit or 100 degrees centigrade. Well, how about on the moon? Any questions? Any answers there? Okay, it boils as soon as the ice melts. Since there's no atmosphere, zero air pressure, it boils right when it melts at 32 degrees Fahrenheit or 0 degrees centigrade. So kind of a trick question. Now here's one of the questions on how far away is the moon. So there you are. You got your car that can drive straight up into space. How long would it take you to get there? Driving at freeway speeds. Now, come on, that's about 70 miles an hour or so. But it took the astronauts about a little less than 3 days to get there. So it was about 1 week. I don't know. Just when you get sick of hearing from the back seat, when are we going to get there?
I think it's B.
Do you think it's that was probably how it was?
After the 1 millionth time that you heard your kids say, "Are we almost there yet?"
It should only take 5 minutes.
Yeah. So here it is, 143 days, and that's constant driving.
No bathroom breaks.
No,
right?
no bathroom breaks, nothing. That's day and night. That's some vacation, and then you got to come home.
My dad used to drive.
So it's a question like this is really designed to show you how big space is. The moon's the closest thing to the Earth, but yet it's still 143 days to get there. Growing up, I think some of us older people remember seeing books of the moon with artists' renditions of how certain scenes would look. So here you have a large crater, let's call it Copernicus or Tycho. Does it really look like this? Well, of course, in a book from 1960, it might, but the answer is no. The crater walls aren't sheer drops. They're more gentle slumped slopes, which is a reason for all that. But a scene like this, no, you wouldn't really see. Looks cool, but
Does look cool.
okay. Now this is one I think some people would have trouble with because they just don't quite understand about how what you can see on the moon and what you can't. But only during a new moon, the moon's dark far side faces the Earth. Because it's new moon, you can't see it, so it's got to be facing Earth. Well, of course not. The far side of the moon never faces the Earth. Never ever faces the Earth. So keep that in mind. Oh yeah. Believe it or not, you had, in the not too distant past, you had some pretty learned people, some pretty smart people who really, really wanted to believe life existed on the moon, even though there was absolutely no evidence for that. Here's one. I think it's pronounced Linné, was studied quite a bit in the 1800s. Is it because some astronomers thought it had vanished and then reappeared? I don't know how that could be. Some astronomers thought it was about to erupt, or other observers thought they saw strange artificial structures within the crater. Now, the correct answer is A. And a lot of professional astronomers were convinced that it had disappeared and then it reappeared. It just shows you what some people see or what they don't see. I don't know. So we're talking 1953 here. That's pretty recent. People knew that there was no atmosphere on the moon, that there was no life on the moon. But anyway, the New York Herald Tribune science editor, John O'Neill, reported that he observed something strange. Was this a canal? He observed a bridge or a road, but a 12-mile long thing. Remember, this is 1953. And some people saw the same thing and other people saw nothing. He believed he saw a bridge, kind of like at Arches National Park. You have some natural formations of huge bridges, but this is 12 miles long. This isn't like 300 feet. So strange. People saw this. But here's a guy who, a professional astronomer, but I don't know where he was coming from. But what unusual lunar viewpoints did William Pickering have? A, Earth has a second moon. Okay. B, the moon has weather events such as fog and snowstorms. Remember, people knew that there was no atmosphere. C, the moon harbors life. So which one did he believe? Did he claim to be true? Oh my God, this guy, he was into it the whole way. Okay.
Wow, what an amazing astronomer, and to kind of miss the mark on all these things.
Yeah, well, there's other amazing astronomers too out there.
Right.
So here's William Pickering again. And this is more than really just one crater he talked about, but Theophilus, the central peak, what did he observe there? He did this with many other craters as well. Artificial lights, smoke, or a snowstorm. And he saw a lot of snowstorms on the moon. Okay.
Okay.
Yeah. Oh, here he is again. Observing indistinct dark areas on Alphonsus crater floor, which is a nice, relatively flat crater floor. But did he see changing vegetation, sunlight playing tricks on him, which is probably the truth,
Yeah.
or the remains of an ancient sea? Well, of course, didn't want to disappoint anybody, so it's changing vegetation. Now, this was in the 1800s. People knew that there was no atmosphere on the moon. I don't quite get this. Well, here's another one.
Wow.
Bavarian observer Franz von Paula, screw up the name, Grüsthusen, was an early proponent of the belief that meteor impacts formed lunar craters. Okay, check that one off. He's right. He also remembered for seeing something in 1822 in Sinus Astrum that was very remarkable. He, with other people doing the same thing, claimed that he saw A, a large walled city, B, a large reservoir, B, a volcanic eruption, and D, a meteor strike. Well, let's go with the weirdest one, a large walled city.
Wow.
And he wasn't the only person, supposedly. He had some backup. Okay, just have a few more of these. When the moon is about 7.5 days old, an unusual feature becomes apparent, one that observers like pointing out. And I've tried to find this myself a few times. It is visible for a few hours each month when the moon's terminator passes it. This feature is called the lunar plus, the lunar X, or the lunar cross. So you kind of see that there's a plus cross X formation that you can spot, which is just a confluence of several craters coming together with the light striking it just right. Well, it's come to be known as the lunar X. It is interesting to see. It only lasts for a few hours and the sun rises high enough. Yeah, a couple more of these things. The maiden on the moon. It's an interesting feature to see. It's just, as you can see, it was in the late 1600s when it was first noticed. No one actually thought it was a maiden on the moon, but they just saw the resemblance. And you can see it actually tonight and tomorrow night will be good times to view this. And then really the best way to see it is if it's slightly out of focus or if the sky is fairly hazy. If you get too sharp of a focus, the resemblance goes away. So where is it? This is the Valles Alpes, which is the Alpine Valley, Mons Pico, or Promontorium Heraclides. Well, this is off Sinus Iridum, and it's the Promontorium. It's something to look at. If you have a chance, go out and give that a look. As I said, if it's in sharp focus, you really won't see this. So, okay, here we go. Who was the first person to smell the moon? I mean, is that possible? What does lunar regolith, the dirt, smell like? Does it smell like, this is a two-part question, obviously. Does it smell like tobacco? Smell like a nice spring rain? Or burnt gunpowder? Well, think about it. The first people who actually smelled the moon, well, it had to be either Neil Armstrong or Buzz Aldrin, the first two people who walked on the moon. That no, they couldn't smell it while they were walking on the moon, but when they got done with their EVA and they crawled back in their lunar module, and they take their helmets off to dust themselves off, well, they're going to be smelling the dust all over them. And they and the other later astronauts said the same thing, kind of a burnt gunpowder smell. But after a few hours, being exposed to the oxygen in the lunar module, or lunar lander rather, it went away, subsided. Everybody's favorite topic, flat Earth. Okay, if the Earth were flat like a coin or a cylinder, well, since the Earth is flat like a coin or a cylinder, see, I should approach this differently. Moonrise were occurred at the same time for any point on Earth. Okay. For a total lunar eclipse, as we're coming up this coming month, just after sunset, the Earth's shadow cast on the moon would not be round, but a long, thin oval, similar to the outline of a coin seen edge on. Or everyone on Earth would see at the same time the moon in the sky. So this is what we see. I mean, since the Earth is flat like a coin, we must see this. Well, of course, no, we don't see any of these things. And so if you have a model which states this, that model has to take into account all these deficiencies in it. And of course, it's kind of hard to explain away some of these very obvious things, which I know, but it gets people laughing. But you know, it really gets people talking. If you do, people will like saying stuff like this, but if you do talk to them about it in a forthright manner, to try to get them to see that no, that is not what you see. So what's going on? Okay, I have one more, which isn't a question, but it's to show you what I've been doing or trying to do, something called ghost craters. Halloween here, ghost craters. Over the past year or so, I have been spending a lot of time observing the moon, something I really like. The guy up in the upper left is the last one I want to mention. But there are a number of ghost craters. Now, a ghost crater is one that's been, it was a normally formed crater that many years after it was formed was flooded, probably by basaltic lava for some reason, and buried or almost buried. When that lava had cooled and subsided, you could see the outline of features just below the surface or just poking above the surface. And that's what these craters are. There's one called Stadius, which the two prominent craters you see in the upper right are Copernicus and Eratosthenes. Well, Stadius is kind of between them, and you have to have a really low sun angle to find these things because they don't rise very high above the surface if they do. Lamont, there on the lower right. That's an interesting one because that happened to be right near the Apollo 11 landing site. And if you get a very low sun angle, you can see it fairly easily with a small telescope. Lambert R, this is a picture I took about a couple of weeks ago, and it is just north of Copernicus. Again, it's you can just barely see it on a low sun. Obviously, it's a low sun angle there because the terminator is right there. Now, for the upper left, this is one I'm particularly interested in. It can be seen, well, I believe, on Sunday night. So I'm looking forward to clear weather, which is forecast for here on Sunday night. It's been nicknamed the Cheerio crater. It happens to be right next to a small crater called Angstrom, which isn't that hard to see. But can you see the little Cheerio next to it? And I think that looks really weird. So hopefully I'll be able to see it. Obviously, I got the Apollo 15 photograph of it, but from Earth, well, I'd like to see what it really looks like. You know, so some of these questions, I want people to get thinking about the moon, what causes certain things, what people have seen in the past. You know, why do these people believe they kept seeing signs of life? And believe me, I could have doubled the length of this presentation with more of that stuff. There are a lot of people who believe they had evidence, proof for life. Strange. You know, when you know at the same time, people knew that the moon had no atmosphere or very, very tenuous atmosphere, couldn't support life. Plus the physical nature of the moon, the relationship between the Earth and the moon. With the moon, from the moon's point of view, the Earth is always in the same part of the sky, almost. I don't want to get into vibration, but there's a slight wobbling around. But the moon is in the same part of the sky. It's always going to be there. So you're never going to have that Apollo 11 picture of the moon, of the Earth rising from the Apollo 11 landing site, because the moon never rises. It's always in the same part of the sky. The moon is far from the Earth. A series of questions which I think were always interesting were, what does the moon look like from another planet? If you were on a spaceship orbiting Venus, could you see the moon? Could you separate the moon and the Earth? Well, yes, you can, pretty easily. Same for Mars. You can separate it pretty easily. And I think you can also separate it if you happen to be somehow standing on the surface of the sun. Because the moon is 240,000 miles away. The angular separation is enough for you to see all that stuff. Okay, well, on that happy note, I will stop sharing. And any questions on any of this here?
Well, let's see. There's a comment here. Harold Locke watching on YouTube says, I thought early from my poor focus, I saw structures on the moon.
Well, maybe that's the reason.
It could be. It could be.
Could be. But I encourage you all to get out and look at the moon when you can. It's an interesting object. It's really the only other world besides Earth that you can view up close firsthand. You can see mountains, craters, and all that stuff. You can't see that on any of the planets. So give it a shot.
Yeah.
Thank you.
All right. Thank you, John. That was really interesting. Now we know who to go to when we need questions for our questions at the global star parties. You have a supply.
That's right.
Yes. Thank you very much. Appreciate it, John.
You're welcome.
Next, we're going to go to Mary Adams. Now, Mary Adams, I listened to her at Aurora Summit. She is amazing. I love the folklore, the history. She is going to bring us to a whole different level. So, she is a star lore historian and author, hosts a weekly public radio show and podcast, The Storyteller's Night Sky. Her book, The Star Tales of Mother's Goose, is a whimsical example of how we reach the stars through the humanities. Mary led the initiative to establish the 9th International Dark Sky Park worldwide, which was achieved at Headlands in 2011 in her home state of Michigan. And Mary, you did an amazing job with the Dark Sky Park. I was there. That was the first place that I did meet you, I think, was up at Headlands when there was a speaker there. And you were amazing. I love listening to you. So without further ado, please go ahead and.
Well, thank you very much, Terry, for inviting me and for that. I don't want to thank you for setting the bar so high, but I do want to say that I'm honored to be joining such an illustrious group. And we've been with Molly, took us to the nebula, and Bob through the black holes. And Terry, those aurora pictures were amazing. And John, I liked all of that stuff about the moon. And then also want to say thank you to Scott for pointing out that part of the reason we talk about the dead at this time of year is because we're drawing close to the cross quarter, or the halfway point between the autumn equinox and the winter solstice. And so I'm going to bring us all the way back down to the earth, and we're going to have to rely on our own imaginations, because the tale that I'm going to tell comes from a time before there were telescopes, before there was machine technology that we could use for deep space imaging, and the kind of science that we have now to figure out some of these fabulous mysteries that surround us and continue to boggle the mind. And I'm kind of, I think, heartened in the fact that you start with David Levy, and he started by reciting a poem. So we're going to end with a fairy tale. And also, I think, Bob, you mentioned Einstein, and I think it's a really wonderful story that I've heard about him. And I'm not sure if when Jack Zipes told this story, if he was bending it to make it true for him, or if this is really how the exchange happened. But Jack Zipes is a scholar of wonder literature. And he told the tale of his grandmother speaking to Albert Einstein and asking him how could she ensure that her grandson would grow up to be an intelligent young man. And Albert Einstein said to him, read him fairy tales. And she said, okay, thank you very much, Dr. Einstein. What else? And he said, more fairy tales. And so what I understand from that story is that a healthy imagination is a very important thing when it comes to doing any kind of scientific research. And imagination, not just because we have to have a make-believe, but we have to have a healthy openness to things not always being what they seem. I think we just got a really good example of that with the questions that John shared with us and some of the things that people have believed along the way, kind of crazy. All right, so I'll share my screen for just a moment, but we're not going to see pictures of some of the beautiful images that we've seen, but I just want to point out the part of the sky that I want to talk about. And that is going to, hang on just a minute, that's going to be the region where, this is actually a star map that comes from Michigan State University Abrams Planetarium. And this is their September map. So even though we're already in October this year, they didn't populate the star field as much. So I wanted to pick up the September map because I want to talk about the region of Pegasus. So Pegasus is just midway on the left-hand side. And you'll see the Pegasus as the winged horse. He's north of the Aquarius water urn and just a little bit west or north also of the fish of Pisces. We have the southern fish there also. So we have this kind of watery region going on. And it's interesting in ancient mythologies to me, particularly coming out of the Greek culture, that the horse was considered the offspring of Poseidon, the god of the waters. And in fact, the Greeks at a certain point went so far as to say that Pegasus was the son of Poseidon and Medusa. And that when Perseus slayed the Medusa and the blood from her being decapitated fell into the ocean. I mean, here's a gruesome Halloween image that out of this union of the blood of the head of the Medusa with Poseidon, the winged white horse Pegasus appeared. And so this is the region of the sky that I wanted to talk about with my subject, which was passing between the worlds under October skies, because the horse also shows up in a lot of tales about crossing over the boundary from this world into the next world. And also horses figure pretty consistently in traditions of celebrating funeral ceremonies and funeral rites. And there are in many, many places around the world, there are grave sites where there will be great warriors that were buried together with their horses, a horse that would be fully saddled. And so this idea that it's a horse that takes us across the threshold from life into death, or even from that other world back into this world. So the horse has this really marvelous mystery that's wrapped around it. And in Welsh tradition, it's the goddess Rhiannon who rides this horse, and actually she's kind of chained to the horse. She's being punished, but what she ultimately becomes is this guardian goddess that can take dead souls back into the afterlife. But the tale that I want to tell actually comes from the Russian. And I was telling my daughter earlier today about this. She's an MFA candidate at the University of Virginia in poetry. And she wrote a little poem today with this line that I particularly liked, that a constellation is a poem made of stars. And so with tipping my hat to David and to Edgar Allan Poe, and then also now to the poets and the writers of fairy tales, and to all of those who, all of us and our rich imaginations. Now I'll bring us back down to earth with this Once Upon a Time. And the story is called Ivan and the Chestnut Horse. And it goes like this. So once upon a time, there was an old man, and he had 3 sons, and he taught them everything that he could as best he could, the way a good father should, so that they would grow up to be very responsible and caring young men. And unfortunately, because he was at the end of the life, soon he knew he would die. And as he was dying, he said to his sons, "You must promise me one thing. Do not forget," he said, "do not forget to come and read the prayers over my grave." And then he died. Now, the 3 brothers, the 2 older ones, were very strong and very brave men, and they were crying and crying. And their younger brother, Ivan, he was kind of still young, very thin, and didn't look like he had much vitality in himself. And he just stood very quietly in the corner as his father died, and his eyes filled with bright wonder at this sight. But he kind of kept to himself. And after they had the funeral service, then they buried their father. And then later that same evening, Ivan went out and prayed over his father's grave. And on his way back into the town, a mighty horse came galloping by with a messenger on it and with a big silver trumpet pronouncing that the king was issuing a proclamation because his daughter, the princess Helena the Fair, had commanded to be built a temple with 12 columns and 12 beams, and she was going to place herself on a high throne in this temple, and whosoever could on his horse jump high enough to kiss her as she leaned forward from her throne would then be made her husband. And ideally, they would live happily ever after. Well, you can imagine that this news spread like wildfire throughout the kingdom, and all the young men got very excited about how they were going to prepare themselves for this great jump to win this marvelous beauty as their own. Well, the three brothers got together, and the two older brothers were really excitedly talking about this. But the youngest brother, Ivan, said, "But wait a minute, our primary task is to be sure to say the prayers over the grave of our father." And the oldest brother said, "Well, that's all well and good, but I really need to take care of the farm that he left to me, so I can't be the first to do it." And the second brother said, "And I need to settle the affairs of the state, so I'm not available to do it either." So the youngest brother, Ivan, said, "All right, I will go. I will take care of saying the prayers over our father's grave." So he did this for the first 7 days, and then he met up with his brothers again, and he noticed that their hair had been trimmed and they had dyed their mustaches, and they were looking a little bit more muscular because they had secretly gone off to their respective places to get prepared for this mighty jump to win the princess, unbeknownst to Ivan and unbeknownst to one another. Well, so they had this meeting, and the oldest brother said, "You know, I still have a bit more work to do, so I'm not able to do the prayers yet this week." And the second brother said the same thing. So Ivan said, "All right, I'll say the prayers again." So another 7 days went by, and then Ivan held a council. He said, "Surely by now you both should be ready to do your turn." But no, they didn't have chance yet. Ivan said the prayers for one more week, and then when he tried to have a meeting with his brothers again, they didn't even show up. Well, pretty soon this contest was going to happen, where now all the men in the kingdom would come on their horses to try to make this jump to kiss Helena the Fair. And so the older brothers, they felt a little twinge of conscience that maybe Ivan should be invited to come and see this competition. And also they had found out that each other was also going to compete to do this. And there was a little bit of jealousy going on, but they decided that Ivan was so scrawny and he was so young that it might be an embarrassment to have him there. So they decided that they would go without announcing to him that they were going to participate in this competition. So the competition went on all day, and several of the men tried more than once, but none of them could jump high enough to meet the luscious lips of the princess. Now, at this time, Ivan was doing his evening prayers over his father's grave. And at that moment, something seized hold of him, a tremendous longing to see the face of the beautiful princess. And he was so overcome with longing that he fell down on the earth and cried deep, deep tears that fell down into the earth and actually made their way into the coffin of Ivan's father. Well, Ivan's father shook from his coffin and stood up and shook the earth off of him and stood before Ivan, who was terrified at seeing his dead father there. And he said, "No, no, my son, don't be afraid, for I have heard your wish and I can help you. I know that you long to see the face of the beautiful Helena the Fair, and I can make that happen." And before Ivan could say anything, his dead father made a loud, loud call that went thundering through the world. And as it faded, the echo of it sounded as though it was like the hooves of a horse. And then his dead father made a second loud call, and now Ivan was certain he heard the neighing of a horse. And then at the third loud call of his dead father, sure enough, this beautiful chestnut horse appeared before him with an arched neck and a flowing mane and tail, and it had fire coming from its nostrils and through its mouth. And the horse went 3 times around Ivan and his father, and then it stood still and said, "Whatever is your will, I take that as my command." Well, Ivan was trembling a bit. He's standing there with his dead father, and now he's seen this very spirited horse, and his father said, "Don't be afraid." He took him by the hand and led him over to the horse, and he said, pass through the right ear and come out the left, and then you will be able to command this horse. So Ivan decided he had nothing to lose. He entered through the right ear of the horse, and when he emerged on the left side, he was no longer a young, shivering boy, but he was tall, upright, and looked very much to be a man of the world. And mounting on the horse, they took off toward the temple that had been built with the 12 columns and the 12 beams by the Princess Helena the Fair. Well, she was at this point pretty disconsolate because nobody had been able to achieve this challenge that she had placed before them. And the older brothers were there, and everyone was getting ready to leave when they heard the thundering hooves of this chestnut horse come riding in. And Ivan mounted on this horse. They jumped up once, but they missed the lips of the princess. They jumped a second time. They got so close that Ivan and Helena could smell one another's breath. And a third time the horse jumped and seemed to pause, and they lingered in a long kiss of first love. And then as the horse lit back on the ground, it took off, and Ivan disappeared just as quickly as he had shown up. But the princess fell back into her temple. She was so overcome with this kiss, she knew that this was her true beloved. Ivan, on his part, was also so distracted by the power of this kiss that he kind of let go of the reins of the horse, and the horse took him back to the site of his father's grave. And Ivan got off the horse, and the horse galloped away. He saw a beautiful rainbow bridge appear, and the horse seemed to go up across the rainbow and be gathered into the folds of the great beyond. And then Ivan looked toward his father's grave, and there his father stood once again. And he said, "Ivan, you have fulfilled my last wish of saying the prayers over my grave. But that was my dying wish. I have one living wish, and here's how you can fulfill it. There will be a great gathering tomorrow because the princess seeks to find the one who was able to achieve her challenge, and you must go, but you must stay in the shadow and speak not a word and watch what happens." So sure enough, the very next day, there was this meeting. Ivan went, and his brothers went, and the whole community went. And the princess looked around and passed by the brothers like they were so much dirt, and looked everywhere. She couldn't see anywhere her true beloved, because although love is blind, it can yet see the truth. And pretty soon she made her way into the corner where Ivan was hiding, and she saw him and realized this was her one true beloved. So they were married, and they lived happily ever after. So I like this story out of the Russian folk tales because I imagine that the horse that makes this great jump that comes from the far, far reaches, that's called by somebody who's already died and is across the threshold, could be related to Pegasus, and that the princess could be related to Andromeda. And perhaps the star Alpheratz, where these two constellations, the star that they have in common, could be imagined either as Ivan or as the place where their lips meet in true love. But also what I love about a fairy tale is that it's not just that there's always a woman in distress that needs to be rescued by a man, that really it came out of a time when it was believed that the human being needed strong moral imaginations to understand the language of the soul and to understand how to free that higher, greater understanding. And I think how to touch that place, like what you were showing, Terry, in your beautiful imagery of the nights of the Aurora Borealis. Something begins to move in us. And in a time before we had telescopes, before humanity had cameras for taking night sky photography, before there was a certain set of scientific ideas about how to understand these phenomena that we see, there were fairy tales, there were mythologies, there were these ideas that were populated with creatures of the other world that we might laugh at now, but it was really trying to give expression to the living nature, the living quality of the human being in relationship to the environment. So I just wanted to show a picture that comes out of the Russian tradition that shows Ivan on his chestnut horse at the moment that he's kissing Helena the Fair, because it's just this beautiful imagination, I think, that together with all of the other wonderful pictures that we saw tonight to end our evening with a happily ever after, that we may all find our true love. And what I think is also important in this experience of the, let me see, stop screen share, in thinking about the wisdom that comes out of fairy tales, is that like Einstein said, that it nourishes the soul. And just like we eat food to nourish the body, a fairy tale nourishes the soul, and long after we've experienced it, it continues to do its work. And I think it lends itself to the sense of awe and wonder we can have when we see the phenomena in the night sky: comets, falling stars, the crescent moon next to Venus, the northern lights, and to even contemplate something like a nebula or a black hole. I mean, these are awesome, awesome images that I think the ancients knew some of that stuff, you know, talking about how Cetus was born from the Pontus region of the Black Sea, which was this swirling black region where devouring monsters were born, and you didn't want to go near it because you couldn't escape. Sounds a little bit like a black hole. So that's the story that I have to share for us. And if anybody's interested in has any questions about fairy tales or about how to find them in relation to the night sky, I'm happy to answer that. But also just to say thank you, Terry, for asking me to join.
Sure. Thank you. That was beautiful.
Yeah, I think everyone's stunned.
Yeah.
Including me.
Ivan and the chestnut horse.
I'll remember that.
It was amazing.
That was. Thank you so much.
Yeah.
Thanks, Mary. I like Alpharats being the kiss.
Yeah.
Perfect. It just seems
I mean, it's good to have those things
exactly
tucked
in the
in
right
there.
place.
Yeah.
Yeah,
And also
that's
just
exactly
that, you know,
right.
the horse is coming up at this time of the year, and it comes to its highest place as we celebrate this season of honoring loved ones who have died, and the role of the horse in this moving across the threshold from life into death. It's not happenstance that this is the season that ancient and indigenous cultures practice these things, because they really were trying to live in harmony with the cosmos. Yeah.
That's
Very
amazing.
you know, I thought when I first saw your topic, I thought you might have, we're going to talk about the Pleiades and Halloween, and that sort of being a transition from the dark world into the living world. So I never, it was a pleasant surprise.
Oh, good. I'm glad that I was able to surprise you. Yeah.
Oh, totally. Yeah. I don't know much. I mean, I know basic mythology stuff, you know, from studying the constellations, but that was a great story. And I usually know them from the Greek tradition, you know, Greek and Roman.
Yeah. You know what I
Oh,
do?
there you go,
When you have to have a lot of star names in your back pocket, right? Like you have to know the names of the stars in order to then start to look for them in other things.
Right.
And because I had 4 children, I read them a lot of fairy tales. And so I have a lot of star names and a lot of fairy tales. And at a certain point, they kind of all just come together like,
Very nice.
oh, you know, it's not too far-fetched to say that this fairy tale about this horse jumping through the sky, connecting to this woman, could be like Pegasus and Andromeda. You know, maybe that's not what the Greeks were saying, but is this where that story is coming from? So I allow myself to imagine those things, and then it's like new worlds open up just in the world of wonder literature. It's really exciting.
Well, I think there's so much symbology in things. I mean, horses represent things, and maybe there's a commonality of that symbol among different cultures too.
In different cultures, it's really prevalent. This idea that the horse is the guardian that takes us across that threshold is really, as you said, really prevalent. Yeah, so it's a good time here for that story.
I hope I find my horse when we're ready to hop into that black hole.
Yeah.
I'm not going any other way than on horseback.
Yeah. Have you ever been barnstormed? Have you ever been ridden a horse when it wanted to get back to the barn, no matter where you thought you were going?
No, I haven't. No.
Yeah, well, it's a little bit like going toward a black hole.
I would think so. Yeah.
Like, hang on. You're not turning. You're just going in one place, and it's up to the horse.
Where barnstorming comes from.
Yeah, I think so. Yeah.
Maybe. Yeah.
I never knew that.
Another word for event horizon.
Yeah. Well, I'll see if I can work. I love anything I can find to work in. I usually will try. So.
Yeah.
Well, thank you so much. That was amazing.
Yeah, it's fun to share a story. Bring us all
It
back
is.
down to earth and then send us
Yeah.
off to sleep with a happily
But you
ever
look at everything a little bit differently with something like that. And then that's what we need. We need to get our mind open up a little bit and thinking in different ways too. So thank you. That was perfect.
exercise the imagination, right?
Yes, definitely. All right. I am going to announce the winners of the door prizes. So let me get this started. I was listening to everything and all of a sudden I realized, oh my gosh, I'm running out of time. All right, here is the answer. We have a lunar eclipse coming up Friday, November 19th. It is not a total lunar eclipse. The answer is false. At mid-eclipse, it will be 97% of the moon will be covered by the Earth's umbra. It's going to be pretty darn close. Mike Naper had that correct answer. What telescope just took a 16-day ocean voyage that covered 5,800 miles? It's the James Webb Space Telescope. And Rich Kraling had the correct answer for that. And what date does a Orionid meteor shower peak? October 21st. And Beatrice Hines had the correct answer for that. So congratulations to all three winners. Somebody from the Astronomical League will be contacting you in the next few days. So for tonight, I would like to thank all of our speakers. My gosh, Scott, thank you. You are the master controller tonight.
Master controller.
David
The master
Levy.
cylinder. Yeah.
Master control program.
David Levy did an amazing job on his reading. Carroll Iorg, president of the league, always great. We get some fantastic updates on what's going on. Molly Wakeling, love your stuff, love the talk. Thank you for your spooky nebulae talk of the night. That was amazing. Astro Bob, you're just as great as ever. Thank you so much for the black hole talk. John Goss, boy, he is going to be the master of the lunacy. I can see the next banquet at the league. We're going to have fun with that. And Mary Adams, that was amazing. That was different, honestly, than what we've probably ever heard. And I think that is a great thing to do because it was just amazing. Thank you.
I have to tell you, it's a little bit daunting to step into the space that all of you prepared and then say, once upon a time.
Thought it was perfect.
It
Nice to
was.
have a
It was
variety at these things.
Yes, and we need variety. And tonight we had just that. We had a variety of everything. So next AL Live will be November 15th. That will be the Astronomical League's 75th anniversary. We are working on that show now. It will be full of surprises, I'm sure. I don't know just what surprises yet, but that's part of the fun. So beyond that, I think it's time to wrap up unless anybody has anything else they would like to say. All right. Thank you all for being here. You all did an amazing job, and it's so good to see everybody again. Hopefully sometime we'll be able to see each other in person. Thank you all for everything, all the talks. They were great.
Thank you, Mary. Or thank you, Terry. I really appreciate it.
Terry.
Thank you, Mary. And
Yeah, thank you, Bob.
Terry,
And Molly,
Terry.
and Molly and Scott and everybody. So
Yes.
Thanks so much. It was really a pleasure.
It's a pleasure to have you here. Thank you so much for speaking. And we will see everybody hopefully in person sometime next year if we're lucky. Or Bob, I guess I'll see you at Aurora Summit as long
see you
as
there.
Yeah,
see you there,
that's
Terry.
the
I think
plan.
we'll have some fun.
I plan on it. See you there. Thanks, everybody.
Good night.
Bye-bye.
Thank you.
Good night. Good night,
Good
everyone.
night.
Good night.